Hello. Okay, hopefully it's audible now. Sorry, just a minute. Let me switch. Okay, so we're gonna solve. I think I got this paper from one of my students. So let's also start solving now. Okay. Good afternoon. Good afternoon. Yes. Okay. So let's get it started. Okay. So how was it, guys? So what is your, before I start looking at the paper, you guys can tell me what do you feel about the paper? Is it was it on the easier side? I'm hoping it was easier than last time. It was easy. Oh, it'll be very close then. Okay. All right. So let's get it started. Let's see if we can finish it quickly. So let's start with the first question. Yeah, I think it can be very easily. Let's see. So we'll rate the questions according to the chat and mine and the chat opinion together. Say which ones were easy, which ones were not. Let's see. So let's go ahead. So let's start. So the first question. The first question says the smallest positive integer that does not divide 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 is what? 11? What is this? Am I missing something? What is the answer, guys? Isn't it 11? Am I missing something? No. What? Alright, the number of 4-digit odd numbers having 1, 2, 3, 4 each occurring exactly once is. Who said this paper? Okay. Alright, so I don't get it. Okay, alright. Let's do it. So there are 4-digit odd numbers. So you have to end with 1 or 3. So you have 2 choices, and then whatever, we don't care, but the rest each should occur exactly once. So out of the remaining 3, you have 3 choices, 2 choices, 1 choices. Is this correct? 3 2s are 6, 2s are 12. Yeah. What is going? Okay, I hope it will pick up. The number obtained by taking the last 2 digits of 5 power 2024 in the same order is okay. Okay, at least okay, better, slightly harder, right? But is it so? Because it is last 2 digits, right? I mean, if the last 1 digit, it was like stupidly easy, right? But last 2 digits is like mod 100. So maybe that's the thing. Is that the problem? So we have to do mod 100, or maybe people see pattern. Pattern will take a bit of time for mod 100. So what do we do here? One thing is Euler-Stoichern theorem will tell you, oh, Euler-Stoichern you can't apply. It's because 5 power, right? So what is it? 5 squared 25. It's always 25, you know, ending. Any 5 cube, isn't that it? Actually, it's because it's 5. I didn't notice it's 5. Okay. Isn't it just ending with 25? Whatever you do, right? Yeah. So even that was easy. What is this? Okay. They must have given some 7 power or something, and suddenly it would have been like, you know, you have to do some Fermat's little theorem or something. Or no, sorry, or Euler-Stoichern theorem. Okay. Problem 4. Let ABCD be quadrilateral. ADC is 70, ACD is 70, something. Okay, let's try to draw some bad looking drawing. So 70, another 70, so it's like isosceles. ADC and oh sorry, this is ADC and ACD, huh? Okay, so let's draw the triangle of, okay, so let's draw the isosceles triangle with 70 and 70, and ACD, both are 70, and ACB is 10 and BAD is 110. Okay, something like this. Okay, BAD is 110, and and ACB, okay, this fellow, okay, ACB is 10, okay, fine, whatever. Now what do they want to know? What is measure of CAB? What is CAB? Okay, so in other words, you need to figure out what this angle is. I think I've drawn it wrong or something. This is wrong. That's why it's a tricky question, right? Maybe I've drawn it wrong. Let's see. So, or it's too easy, right? I mean, this is 70, 70, and what remains would be 140, 40. It will be 150. That would be the easy answer. Is that easy? Am I making a mistake? If I roughly try to plot, so I'm just, can't be this easy, so I must have made a mistake. So let's just see. 70, 90 is like this. So roughly 70 is something like this. Isosceles triangle with 70, something like this. Okay, roughly. And ACB is 10. ACB is 10. Oh, I think I labeled ABCD wrong. No wonder. Okay. Oh, you can't see the screen? Oh, you can't see the screen. Sorry. Let's just see. Okay, I don't know why it's not visible. So let's just performance mode or something like that. Let's see. Okay, now is it visible? Okay, I don't know. Okay, it's not visible still. Just a minute. Okay. Sorry, so let's just see. Movie recording. Okay, so let me just fix it. Is it visible now? Can you see the drawing? Yeah. Okay, cool. Right, so I'm trying to see if I made any mistake here. Okay, sorry for the sound. Switch off. Alright, so did I make any mistake or was it too easy really? So ACD, the ABCD should be in order. So ADC is 70, ACD is 70 and ACB was 10. Okay, fine. So I think I did a drawing mistake. So if you're not careful, you'll make that mistake. So ACB was 10 and BAD was 110. Okay, BAD was 110 here. And you want to know CAB, so you need to know this angle. Okay, all right. So you already know. I don't get this. So you already know ADC is 70, ACD is 70, ACB is 10, BAD is 110. 70 plus 70 140, remaining is 40, and what remains here is 70, 80, and whatever remaining is 100. So is there an issue here? I don't think so, right? Answer was 70. What did you guys get? Yeah, what is this? There's not, it doesn't look like an Olympiad cell set it, you know. Okay, fine. I can't believe it. I'm just trying to be, I'm like that. We're going to, you know, we're going to make mistakes. There's some sneaky question here. Okay, all right. AB minus C. What is going on? What is this? Okay, all right. So x by y, y by z, whatever. Okay, so z by x and x by z and all are like, have they just taken reciprocals? Yeah, all right. R plus s plus t kind of a thing this is. And this is like x by z, like 1 by t, 1 by s, and 1 by r and 1 by s or something. And this is a, this is b. I mean, I'm calling x, y, z as like r, s, t and so on. So since it should be an integer, it won't matter at the end. This x, y, z is just distraction, right? So what is ab? AB, that r into 1 by r and all will add up and will give you 3, and then it will give you all possible r by t plus r by s plus s by t plus s by r plus t by s plus t by r or something like that. And this fellow c here is basically essentially x by y, which is r, plus y by z, s into s plus z by x, which is t, into t plus x by y, which is r. Okay, and rst is 1. Remember, x by y into y by z into z by x is 1. So I guess that's the reason. It's just some, okay, I guess maybe r by t, because I wrote r by t, it makes it trickier. Maybe, I don't know. X by y into x by z will be x square by yz, right? And r by s would be x by y into z by y, xz by y square. Okay, so anyway, so if you calculate this, you'll get, what will you get if you multiply? Maybe there's an easy way to do this. AB, do you have to just multiply it out, or was there a smarter way to do this? AB minus C. What do you get? RST is 1. R plus S plus T. Should we do R plus S plus T minus R into R plus S plus T minus S or something like that? Would that be faster? What did you guys really multiply it out? I mean, it's boring to multiply it, or was there some nicer way to do this? RST is like 1. Is x by y, x by z. I think RS is 1 by t. That is true. RST is 1. Okay, maybe I'll just multiply it out. It's wasting too much time thinking of some sneakier method. S square plus st into t plus r, rt square plus s square t plus st square plus r square s plus r square t plus r square plus again rst. Rst is 1. So what is the relation? I think by writing RST is equal to 1 and T is like 1 by RS. So this is essentially 3 plus R square S plus R square T plus S square R plus S square T plus, simply I should have maybe kept it with XYZ only. T 1 by S is RT, T square R plus 1 by ST, so T square S. Okay, so we have it, right? This entire piece here, this 6-term piece is here also. So we are done. So the answer is C is equal to 2, RST and RST is 1, plus what remains is AB minus 3. So answer is C minus AB mod is 1. Yeah, okay. Correct. So it is 1. I mean, I changed the variables. I don't like this because if I multiply fractions, I'll make mistakes. So that's why generally I tend to get rid of them. Okay, 1. Answer is 1. Small. Great. Problem number 6. I think hopefully eventually now it starts getting fun. Find the number of triples of real numbers ABC so that a power 20 plus b power 20 plus c power 20 is equal to 1 and a power 24 plus b power 24 plus c power 24 is equal to 1. What is this? Who find the number of triples of reals where you will get, what is this, a power 20 plus b power 20. You guys solve it? Okay, so what did you guys do here? So let's see. Find the number of triples of reals. Why is, oh sorry, it's the same ABC is giving, that's why, right? A power 20 plus B power 20, and say that's if ABC, yeah, I think it's plus or minus 1 maybe, right? I mean, 1 is plus or minus 1, the rest are 0, those are possibilities. That already will give you, I mean, permutations of plus or minus 1 comma 0 comma 0. That's certainly one solution, and maybe they are the only solutions, I don't know. If that is the case, then there are 6 solutions. Yeah, the trivial ones. But did you guys prove it, or was it like you thought, okay? I think the answer is the following, that even if one of the ABC was bigger than 1, then I think the problem is that A power 24 will be bigger than A power 20. I mean, if A was bigger than 1 for some A, then A power 24 will be greater than A power 20, and well, the remaining can add up to 1. If A can't be bigger than 1 for sure, all of them should be less than 1. If all of them are less than 1, yeah, because they sum up to 1, no? All of them should be less than 1. But if all of them are less than 1, then A power 24 is less than A power 20, and B power 24 is less than B power 20 if all of them were less than 1, strictly less than 1, right? This will happen, and they are positive because it's even powers, that's why I see, that's it. So then the sum will be strictly less, it contradicts the equality. Therefore, it cannot happen that all of them are strictly less than 1, at least one of them should be 1, but the moment one of them becomes 1, the rest must be 0 because they should sum up to 1, that's the logic, right? So indeed the answer is 6. But you guys could guess it. I mean, or else there is no way to solve a real system of equations often, so it's not a bad guess. Okay, hopefully that's clear to everyone. Yeah. So determine the, typically bounding, right? Bounding is one technique which you have to keep in mind throughout. Alright, determine the sum of all possible surface areas of cubes, 2 of whose vertices are 1, 2, 0 and 3, 3, 2. Okay, 1, 2, 0 and 3, 3, 2. 2 of whose vertices are, what does that mean? What could be the, I mean, the vertices could be, I mean, you should try to draw a typical cube. So supposing you draw a typical cube, what kind of vertices? It can be the nearby vertices like this. Okay, that's one of the possibilities. Or it can be like far away vertex like this, and like this, or like this, are 3 of them. Or it could be the opposite vertex. These are all possibilities, right? And you just sum them up, that's it. I hope, I mean, is that what you guys did? So 1, 2, 0. What if you pick 1, 2, 0 to be one of them, and the nearby is 3, 3, 2, in which case it will be 3 minus 1, 2, 3 minus 2, 1, 2, 2, 1 square, 2 square plus 1 square plus 2 square is the length of the square of the length of the cube. So this surface area is 6a square, right? So the answer would be in that case 6a square. So 3 times surface area. Determine the sum of all possible surface areas of a cube, 2 of whose, okay, only the all possible surface areas, not add for each different ones, okay. So that means 4 plus 4, 8 plus 1, 9, 9 into 6, 54, okay. Yeah, that's what Derby said in one example there. So the next is you move the 3, 3, 2 to the opposite end like this, and that is like a root 2 essentially. And now if you do distance formula, you will again get 4, now whatever, 4 plus 4, 8 plus 1, 9, but this 9 is not the side is 9 by root 2. So 6 into 9 square by 2, which is 6 into, sorry, not 9 square by 2. What am I saying wrong? 6 into 9 by root 2. I think, I'm sorry, square root of 9 is the distance. So 6 into 9 by 2. And I think the answer is 27. That's the other answer. Yes, that's the other answer, correct. So 54 plus 27 plus the other 332 is opposite end here. Okay, and that is a root 3. So that is again 9, root 9 is a root 3. So therefore the a is just root 3, right? So 6 into 3, 18. Yeah, so that's the answer. So you sum up those, you should get the answer. Whatever that is, what is it? So 54 plus 27 is 8199. Yeah. Correct. Problem number 8. Let n be the smallest integer such that sum of the digits of n divisible by 5 as well as the sum of digits of n plus 1 is divisible by 5. What are the first two digits of n in the same order? Sum of digits of n is divisible by 5 and sum of digits of n plus 1 is also divisible by 5. Let's see. So that for that to happen, just if you increase by 1, that won't happen. So that must be, there should be some lot of carry. So it must be like towards the end or something. So let's see. It can happen where? I think it should be like at the boundary, like when you go to 0, 0 maybe, something like that. 9 4s are 36. Is it 4 9 9 or something? I certainly here it happens, I think, right? Certainly it happens here. 9 4s are 36 plus 4 40 plus, there might be a smaller one somewhere. Can it happen somewhere smaller? Like even if 99, 79, 69, how do we solve it systematically? 49. But 49 doesn't work, no? Digits of n don't add up to 5. I mean, the first two digits, you mean? Yeah, the first two digits could be 49, yeah. But we have to prove it. That's the intuitive guess. Oh. I think Nabanu is noting that he counted the area of sides only. I mean, in side square, you mean? Oops. Okay, here, how do you prove it though? I think this is true, right? I think this is true intuitively. Just that, is it a rigorous argument? First of all, I think it's true that it cannot happen anywhere in between, because when you add plus 1, it will only increase n plus 1's modulo by 1. So both can't be divisible by 5. For it to actually change, it has to be just before some multiple of 10, like some 100 or whatever. That is intuitively true. But any other 9 if you have a bunch of 9s ending, why do you need a bunch of 9s ending though? I'm not sure actually. Is this true? How do you do this? Sum of digits. What is sum of digits though? But sum of digits is modulo 9. But modulo 9 is not a good idea. I want to do modulo 5. Should be 0. 49. Yeah. Oh, you took the cases and did it? 9k plus n mod 5. 9k plus n mod 5. I see. Like, what is the rigorous way to do this? So 9k plus n mod 5. What does that mean? I guess I mean, in principle, you should really take a0 plus a1 10. I mean, full a2 10 square ak 10 power k, some k digit number. Then you add 1 to it, whatever. But then when you add 1 to it, the digits will change entirely. If I write like this, I don't know if it's useful. It's divisible by 5 would mean what? A0, the sum of the digits is divisible by 5. What does the sum of the digits divisible by 5 mean actually? It means a0 plus a1 plus a2 plus dot up to ak is divisible by 5. We could pull out one a1, a2, a3 and do something. Subtract 1. No, I don't know. I guess we could brute force argue that because it's small enough number, we could argue that in the 2-digit cases it will never happen, 59, 69, 79 and so on, because when you add 1 to it, the 9 will convert to a 0 and 7 will increase by 1. So carryover, yeah, okay, I think it's clear to the carryover, right? In the 0 to 100, the carryover will increase only 1 digit. It will convert 9, it will remove 9, 9 is subtracted, you subtract 9, but then you add 1 to the leading digit. So the changes by 8 actually, okay, it changes by 8, the total sum. So if it changes by 8, it can't be divisible by 5. But if you go to triple digit numbers, then what can happen? You can have something like 159 or something. And then what will happen if you try to add 1 to it? Then you will see that it will become 160. It's the same thing. Unless there are 2 9s. Okay? If there are 2 9s. When there are 2 9s, what will happen? Both the 9s will actually go down. So it will be minus 2 into 9 plus 1. So in other words, it will be like minus 18 plus 1, minus 17. Right? So in other words, initially, if you have 1 9 and you add 1 to it, it will only change by minus 8. Or else it will change by, and when you go up, it will change one step ahead, it will change by minus 17 if there are 2 9s, right? If there are 2 9s consecutively, by the way. If there were not 2 9s consecutively, it was like 919 kind of a thing, then it won't matter. It's again just changes by 1. So we always need that 2 consecutive 9s to come at the end. So it will change by 17. And we can run this argument continuously now and reach until it becomes a multiple of 5. So for example, you should check when will this, I mean, what if you have 3 9s? It doesn't matter what this 2, 3, 4 and all this. So this is the last digit here is we just use it to, we just adjust it so that this becomes divisible by, I mean, the sum of the digits is divisible by 5. For example, 9 9 is 18. And if you want it to be divisible by 5, you just put 2 here. 18 plus 2 is 20, divisible by 5. You can adjust it. But the thing is that if you start with the 3 9s, again you will see the same pattern, right? All the 3 9s will vanish, will become 0 and this will increase by 1. So minus 27 plus 1, minus 26, right? So you have minus 8, then minus 17 it changes by, then if you have 3 9s, 2 9s, 1 9 and 3 9s, it will change by minus 20, how much it will change by? Minus 27 plus 1, minus 26. So you'll keep adding 9 to it, basically. You'll keep adding 9 to it. At 4 9s, it's divisible by 35. It changes by a multiple of 5. That's a proof. Okay. So recursively, you just keep adding and showing what happens. Okay, I mean, I'm just trying to finish off the proper proof, okay, instead of just guessing. Okay. Problem 9. Oh, 4 people are watching the stream together. Okay, cool. All right. So, consider the grid of points x. We say a pair of points A, B, C, D in x is a night move pair if C is A plus or minus 2, D is B plus or minus 1, or the other way around. I mean A plus or minus 1, B plus or minus 2. Number of night move pairs in x is. So how many night move pairs do you have if you start from 0 to 4? So let's just see. Let's erase this. Okay, so did you guys get the night move pairs? Let's see what it is. So supposing you have like 0 0 0 1 0 2 0 3 0 4 0 1 0 2 0 3 0 4. Okay, so you have something like this. Basically it's a small chessboard, 4 cross 4 or something they are thinking, I think. Okay, all right. So consider the grid m comma n 0 1 2 3 4. We say a pair of points in x is a night pair move if you start from any a comma b. Okay, let's mark it. Let's understand. If you start with any a comma b and you go either a plus 2 and b plus 1, okay, or a plus 2 meaning a plus 1, a plus 2 and b plus 1 here, or a plus here, b minus 1, or a minus 2, this is behind like this and like this, and this is our usual night move, I think. A1 like this, and this fellow doesn't even have actually below. Okay, so what is the number of night move pairs of these? I mean, how many such pairs can you find? That's the question. Okay, so let's see. Of course, you can try to do it for everything and just waste your time, but there might be better ways to do this. I'm always trying to think if there's a other than brute force method which is cleaner. No, it may not be faster. So what is the ninth problem? Did anyone do the ninth one? No. So somebody in chat is asking 18th one. I don't know what the 18th problem is. If somebody has an 18th, you can maybe tell them. Let PQ be 2-digit numbers, neither of which are divisible by 10. Yeah, I think we'll come to it. Okay, did anyone do the night move problem? How did you go about doing this without brute force, or did you brute force it? Let's see. So how will you solve this problem? You had to basically if you start from here, I think there is a certain symmetry here, right? So how would you do this? There is a certain symmetry, that's clear. A comma B. C is A plus 2. You just write all possible cases. Okay. So let's see. I mean, this is, oh man, if I have to do it by brute force, it is sad. I don't want to do it. A plus 2, so A is equal to 0, then you have, what options do you have if A is 0 and B is 1? No, there must be a better way to do this. Can you do it by generating functions or something? A is 0, B is generating functions. What do you guys think? Can you do it by, I mean, C minus A mod is equal to 2 and D minus B mod is equal to 1 as one possible case. The other is C minus A mod is equal to 1 and D minus B mod is equal to 2. Right? So if I write it like this, does it help? This or this? So that seems better, right? So can I say something like A, B, C, D, I have to choose 4 numbers between 0 and 4 and their sum should be 3 but they are not equal or something like that. Like, I'm just trying to convert it to some single equation or something where it's easy to answer. I don't know whether it is. Can you find solutions to C minus A plus D minus B equal to 3 mod and none of A is not equal to C and D is not equal to B? That's only zeros are not allowed, which means the sum should be either only 1 plus 2 or 2 plus 1, right? So now does it just become easy? I don't know yet. I mean, how many choices do you have? Is it way faster now? Hopefully no. So I guess maybe you can't simplify. I mean, even if you write like this, it won't help. You have to do this only, I think. How many solutions are there to mod c minus a equal to 2? When a and c are taking values from 0 to 4. 0, 1, 2, 3, 4. So is there pick? I am not sure. Is there some faster way to do this? I guess you have to do brute force only. It's very sad. I thought there will be some cleverer way to do this. Yeah, okay. I think there is no other way. Maybe I mean I can't think of any other way. And if I rephrase it nicely, so c is equal to a. I mean at the end of the day it looks like that only, a plus or minus 2. We are going back. I'm going back to the original one. D is b plus or minus 1. I think that we have to do that only. Maybe there was some nicer way to do this by generating function or something. It would have been really cool. Maybe there is. Okay, so c is a plus or minus 2, b is plus or minus 1. So you just add in. I mean, it's independent, right? The whole point is like this is and it's independent. And then you just do it by symmetry, and then you subtract common solutions. Exactly like how Abhi said in chat. So you just put c, a is equal to 0. So if a is 0, then c can be plus 2. Again, you have to list everything now. Very sad. A is 1, then c is equal to 3. A is 2, then now c has two possibilities, 0, 4, and a is equal to 3, then again there's only one choice, 3 minus 2, which is 1, and a is 4, c is essentially 0. 4 minus, sorry, how many choices do you have? 4 minus 2, right? So a can only be between 0 and 4. So these are the values of c, and this is for the first thing. Similarly for d you can do. So if b is 0, again 0, 1, 2, 3, it's very fast once you decide to do it by brute force, I think. 0, 1, 2, 3, 4, then the possible values of d are 0, b plus 1, 2 or 0, for 2 it is 3 or 1, for 3 it is 2 or 4, for 4 it is 3, okay. So therefore you have 1, 2, 4, I mean the 6 solutions plus 1, 8. There are totally 8 solutions here, and here there are 1, 2, 3, 4, 6 solutions, right? Right, so 8 and 6, so therefore you have individually 8 solutions, 6 solutions here and 8 solutions here, totally 48 solutions. So then here you have 8 solutions, here you have 6 solutions, another 48 solutions. But then some are some of them common? Are we repeating everything exactly twice or something? 48 plus 48, because they have said, by the way, they have said bracket, right? So it's not ordered pair, it is unordered pair. That you have to be careful about. Alright, so let's just see. BD is, like for example, if you have BD 0, 2, you could pick I think you have to be careful about when they are equal. Other than the equal case, it should be fine. But there cannot be equal. C equal to a plus 2, then c cannot equal a plus or minus 1. Both can't happen. So there won't be equal cases. So what is the answer you guys got? 34? Oh no, sorry. I think you guys are discussing the marks. For problem number 9, did you guys get 48? Is it 48? a comma 0 comma 2 bd is I went the marks. Okay, yeah, I guess if the paper is easy like this, definitely what you guys are discussing is right. I also guess that will be above 40, maybe cutoff curve will be above 40, but I have not seen the remaining questions. So this one I am guessing the answer is, okay, let me finish off the answer. So 0 comma 2 0 comma 1 is one possibility, but the same thing is on the other side as well, 0 comma 1 and 0 comma 2. So I think it's 48 because AB CD CD AB can be interchanged essentially. Okay, and I don't think there is anything common, right? Yeah, everything will get counted twice. So I think it's 48 is my guess. Yeah. Okay, problem number 10. Determine the number of positive integral values of p for which there exists a triangle side ABC such that blah 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 blah. Okay, how many positive integral values of p for which there exists a triangle with sides ABC which satisfy some squares are there, some completing the squares is what I'll think. There exists a side, I think triangle inequality and some completing the square something. Let's see. So PB completing the square, such standard tricks, no? We have done this so many times. So I'm guessing the first thing all of you would have tried because it's a standard trick. First thing to note is, I guess, PB square you have and you have a PB here. So it seems like you would like to do something with that. And then there is a 3C here. So it looks like you will complete that square, right? PB minus 3C the whole square, this, this and this. And the remaining will automatically complete itself, a minus 3b square. What is this? Doesn't sound like RMO setting. Okay, PB is equal to 3C, A is equal to 3B, and B is equal to A by 3. Okay, what is the plan here now? What do they want? The possibility is that there exist triangles with ABC. Okay, so A is equal to 3B. Oh, I guess they want to use like triangle inequality or something like that. So let's see. So A plus C is greater than B, and A is already 3 times B. So 3B plus C is greater than B is trivially true. So I think the real thing to check should have been, since A is 3 times B, B plus C is greater than A, but A is 3B. So that's same as saying B plus C is greater than 3B. That's same as saying C is greater than 2B, but C is PB by 3 is greater than 2B. So that means P must be greater than 6 is what I'm getting one way. Okay, but you should also get a bound in the other way, I think. So what is the other bound that you can get? A plus something, maybe A plus B is greater than C. Oh, Ranjan, I can try that problem if you want. Before I'll just finish this off and we can try that. So let's see, but this one, let's finish this one. So what do you guys get for P? So P is 3C by B, and C is PB by 3, I guess. PB by 3, I'll keep it this way. This is better. A is 3B, 4B, done. Nice, done. Okay, we are close to it. And then I'll come to it. So P is less than 12. So P is between 6 and 12, right? Done. At least by triangle inequality, P is between 6 and 12. So P can take values 7, 8, 9, 10, 11. I think the other one will not give you anything new because A plus C is greater than B will be trivially true because A is 3B. 3B plus C is greater than B, same as saying 2B plus C is greater than 0. So this is always true. But one of them will give you this bound, the other one will give you this bound. And if all these 3 equations are satisfied, then it forms ABC form a triangle. So answer is 5, right? Okay. All right. So maybe I'll do 18 because Ranjana is asking. Let PQ be 2-digit numbers, neither of which are divisible by 10. Let R be 4-digit number by putting the digits of P followed by digits of Q in order. As P and Q vary, a computer prints. So wait a minute. P and Q are neither of which are divisible by 10. Okay. Alright, so just skips things that are divisible by 10, all ending with 0. Let R be 4-digit number which puts digits of P followed by the digits of Q. Okay, so first P and then Q. Okay. As P and Q vary, the computer prints out R, this 4 digits on the screen. If GCD of P comma Q is 1, or it will print if the GCD of P comma Q is 1 and P plus Q divides R, sorry, okay, if P plus Q divides R, okay. Suppose the largest number that is printed by the computer is n. Determine the number found by the last 2 digits of n. Largest, meaning last 2 digits mean Q. I think they're asking what is Q, right? Okay. Alright, so let's see. So you have two digit numbers, neither of them are divisible by 10. Their GCD is 1. Only one set are printed are when their GCD is 1, but P plus Q divides R. Okay. And one thing to try is what will happen to the largest number if you want to do trial and error a bit before we start understanding what's happening. So if you don't want, so 99 can be the largest 2 digit numbers, but their GCD is 1. So if you take 99 and 98, what would happen? So to make it the largest will be 99, 98. But the problem, I guess, is most likely 99 plus 98 won't divide the 4 digit number. R is the 4 digit number, right? Yeah, which is 9998. Oh, I see. Okay. So R is basically 100 P plus Q, right? R is 100 P plus Q and P plus Q divides it. But 100 P plus Q is already 99 P plus Q. Which means if P plus Q divides R, P plus Q divides 99P. That much we can say, I guess. So P plus Q divides 99P is weird, which means since P divides P plus Q, P must, I think so. So I think, no, sorry, no, just a minute. So I want to use somehow that this P common here. How do I use it? So 99P is P plus Q into K, right? Which means you can write this as 99P minus PK is QK. So P into 99 minus K is Q into K. Okay. So now what have they said? There is no, okay, there's nothing okay other than that. So P and Q have no common factors. See, P and Q have no common factors. So here you have P into 99 minus K is Q into K, and P and Q have no common factors. So which means P must divide K and Q must divide 99 minus K. So, but what is K though? Can we say anything about this? P is a 2-digit number and it divides 99 minus K. Better be that this K is, see, these are all natural numbers, okay, here. So this is a natural number. And if 99, P into 99 minus K is a natural number, 99 minus K is a natural number, which means that K is less than 99. So K itself is some 2-digit number. So P divides some 2-digit number K and Q divides its complement in some sense, 99 minus K. So is that all? That's enough and I use that to solve maybe? Okay, so let's see. So what is the problem with R being 9998? In that method, you'll get this to be 197, I think. So this sum is 197. This is 197. So how do I choose K this way? I want P plus, what do I want? I want Q to be as large as possible, right? I want Q to be as large as possible. I want Q to divide some 2-digit number 99 minus K, and I want Q to be as large as possible. So what can I do? Why not make Q 99 itself? What's stopping me? If I make Q 99, why not? Suppose a largest number, largest number printed by n, sorry, R is as large as possible. right? So as a C, the largest number printed is n. So 99, 100p plus q is as large as possible. So how would you make this larger? 99, 98 is not the best possible. Does that work, by the way? 99, 98, what goes wrong? 197, does it divide 99 into p? 99 into 99, no. Okay, so therefore what will we do? I think we'll keep reducing until this works or something by trial and error. If you had to do a trial and error strategy, we would, can we just make p plus q divide 99 into p? P plus q, this p plus q, actually p plus q should divide 99, no? GCD of p comma q is 1, doesn't it imply GCD of p plus q comma p is 1? Oh, that makes it, that would have made our life much easier. Is it true? It's true, right? By Euclid's division algorithm, this is true. It's equivalent. So which means p plus q and p have no common factors. So p plus q should divide 99. Great. So we know that p plus q must divide 99, and 99 has only very few factors, right? 1, 3, 11, 1, 3, 9, 11, 33, 99. 1, 3, 9, 11, 33, 99. So p plus q, so okay, we already have like a limit on what p plus q can be actually. So we want to make p as large as possible, and p plus q must be one of these factors. We just have to try one of these factors now, right? So all right, so I think we should be able to try now. So let's make r as large as possible. To do that, let's make p as large as possible. For p to be as large as possible, how can we pick? So why not pick p plus q to be 99 itself, the largest possibility, and arrange, we should arrange p in some nice way so that this works. So p plus q is 99. So what can p be? P plus q is 99, then p can be anything actually. What other constraints do we have? P plus q is 99. See, it's already satisfies. If I just choose any, see, that works actually, right? I mean, do you guys see it? If p and q GCD is 1, if I pick two numbers that add up to 99 and their GCD is 1, it satisfies all the properties actually. Because once p plus q is 99 here, notice that p plus q is 99 here, 99 divides 99 into p, right? So clearly 99 divides p plus q divides, p plus q is 99. Does 99 divide r is the question. The 99 does divide r because this is 99 and this already has a piece of 99, right? So 99 does divide. So it satisfies all the required properties. But I don't know that it will give you the largest possible, right? So I'm guessing it should. So if you take p to be what's the largest thing you can take to make it even larger? P to be 98 or something. Or then it won't be a two-digit number. Why not? 98 plus 1. Why not? Right? GCD is 1. It satisfies everything. What goes wrong? So 100 into 98 plus q, which is 1. 9801. This satisfies. But is that the largest? Is that the largest? My plan of making it the largest was pick p plus q to be as large as possible, then make p as large as possible. But is that the best strategy? Any other thing will only be smaller. Is that true? So any other p plus q, if I pick any other factor, p plus q will be less than 99. That's for sure. This is less than or equal to 99. So nobody can beat that in my strategy. But for a fixed value of p, the largest possible value p can take is also 98. Q can't be 0, right? It's not allowed. It has to be, oh, but q, oh, this is not a 2-digit number. Is that the problem? Is that the problem? It's not a 2-digit number. Okay. Yeah, q has to be 2 digits. So q has to be at least 10. So which means the highest possible thing is 89. Yeah, thank you, chat. So 89 plus 10. Then what will you get? Q to be, then you are done, right? So yeah, then I think you can't beat, because other factors are even smaller, right? The sum only is 33. Number will be even smaller, 100%. So this is the answer. So we are done actually. This is the answer. So 100 into 89 plus 10. Whatever is that number, that is the answer. This is the answer. I think this is the largest n, I guess. I am guessing. This is my answer. And the last 2 digits are 10, I think. So we are solving problem 18. So Yogeshwar Rao is asking which one. We are solving problem 18. And hopefully the argument is correct. So let me go over the argument. Let me go over the argument so that you guys can find faults with it if it's wrong. Because I don't know, I'm just solving it on the spot. So basically you have been given you are writing two 2-digit numbers. Oh, you can't. Oh, it can't be a multiple of 10. Can't be a multiple of 10. None of which are divisible by 10. We forgot that, right? So again we have to change 11. I'm trying to make p as large as possible. So q should be 11 and p should be whatever, 88, right? But then they'll have a common factor. Oh, disaster. So 12 and 87 finally. 12 and 87. Answer is I think 12. So okay, this is my now final answer is 12 right now. Okay, I don't know. I think it's correct. So okay, what's the plan? Okay, let me just run over the argument. So I think it's 8712. That is the largest n. Okay. So what is the argument? And you guys can find fault. I'm actually running over it because I also think there might be errors. So okay, here's the argument. So you write two numbers pq and you make it into r, right? Which is a 4-digit number. P and q are 2-digit numbers. P, Q are 2 digits. So P and Q are at least greater than or equal to 10, less than or equal to 99. Okay, somewhere between 99 and 10. And you write down the number 100p plus q, which is r, which is essentially write that p and q as a 4-digit number. Now the computer is printing this continuously. As long as it will print it, as long as GCD of p comma q is 1 and p plus q divides r. Okay. Suppose the largest number that is printed with the computer is capital N, what are the last 2 digits of n? Okay, so that's the question. Okay, now let's run over the argument. The argument goes like this. You just note that if p plus q divides r and r is 100p plus q, okay, then you can write this as 99p plus p plus q, and p plus q already divides p plus q. So what that means is p plus q must divide 99p. So this implies p plus q divides 99p. Now GCD of p comma q is 1. By Euclid's division lemma, Euclid's whatever thing, you can add multiples of q to p and it will still, the GCD will still remain 1. Okay. So because of which p plus q and p, I think I should add it to the other one. P plus q and p have no common factors. Basically, p plus q and p had a common factor of d, the difference will also have a common factor, and this will have a common factor. You could directly argue that way. P plus q and p have no common factor. Now if p plus q and p have no common factors and p plus q divides 99p, that's again another Euclid lemma which says that p plus q therefore divides 99. Great, which completely whittles down the possibilities of p plus q. So p plus q can only be any factor of 99, which is 1, 2, 1, 3, 9, 11, 33, 99, right? These are the only factors it can be, which by the way it's hopefully correct. 3 square into 11 power 1, you should have 3 into 2, 6 factors. I have 6 here. So now the thing is that we have to just, so we are limited to, now we can sort of do case analysis, right, really, because we have only 6 possible cases to try, and now we have to check whether each of these cases work. In fact, if you want to make the number as big as you want, right? So you want to make 100p plus q as big as possible. So which means you want to make 99 p plus q as big as possible. So if you choose p plus q to be as big as possible, 99, okay, then p will, I mean already this you can make it by greedy algorithm. Try to make p plus q large and also try to make p large, okay, then you can choose p to be larger. Actually that will work pretty well because 99's next largest possibility is 33. So if you make p plus q 33, p can only be less than 33 because when you sum up it should be 33, right, and it should be 2-digit number. So basically p plus q is 33, then p will definitely be less than 33. So if you could choose a thing so that p plus q is 99 and p is bigger than 33, we are done. It has to be the largest, right? So so therefore you fix that. You just fix p plus q to be 99, and then there's a lot of sneaky thing here with random conditions like p and q have, you know, neither of which are divisible by 10. They have no common factor, and that's a little annoying. But if you now you want to make r as large as possible, r is 199 p plus q, which is 99. So you want to make this as large as possible. So you want to pick p to be as large as possible. So what is the largest 2-digit number that you can pick for p, so that q is also a 2-digit number, and p and q have no common factors, and p and q they are, you know, not divisible by 10. Then you notice that for q to be a 2-digit number, q should be at least 10, right? Q should be at least 10, which puts a bound on p, that p is at most 89, right? But q cannot be 10 because if q is 10, it's divisible by 10. That's not allowed. So you put q equal to 11. So the next best thing you can say is q is greater than or equal to 11, p is less than or equal to 88. But then if you choose q to be 11 and p to be 88, the, p and q have a common factor of 11, right? So then you say, oh, okay, so then the next best possible p, the largest possible value of p I can even allow at this point is 87, and q is equal to 12, I guess. They add up to 99. And indeed, now p and q have no common factors. First step, both are 2-digit numbers, they don't have common factors, and p and q are not divisible by 10. Of course, that itself means they don't have common factor. Actually, neither of them are divisible by 10, at least. Not both of them, but neither of them, actually. Neither of them are divisible by 10. So all cases it satisfies, and this is the largest possible p we can get. Okay. So therefore, p is 87, q is 12 works. You can put back and check actually. If you put p is 87 and q is 12, here you will get the answer to be 99. If you look at here, this form, 99 into 87 plus 99 will be the number, that is r, and clearly p plus q 99 divides it because 99 is a common factor, and 87 and 12 have no common factors, so it satisfies all the properties. So we are done. Okay, so the answer is p is 87, q is 12, and they have asked what's the last 2 digits, which is q, which is 12. Okay, right. Hopefully clear to everyone. I don't know if Ranjana is around though. Alright, so the answer is 12. At least that's what I think. Question 23. Okay, so let's do questions on demand and then I'll come back to the other questions. Question number 23. Consider the 14 numbers 1 power 4, 2 power 4, blah blah blah, up to 14 power 4. Oh, Rishon is like, oh, Rishon notes that there's a common factor. What disaster. Okay, we'll go to 23. 87 and 12 have a common factor of 3. Annoying. So where does it stop? Q is 13. Please tell me this doesn't have 13. It's just 13 divided 86. 13 3s are 39. 39 2s is 78. 78 to 8. No. I think this is fine, right? 1386 is fine. This is just disaster. I mean, very tricky. You know, if you make one mistake, there's so many traps here. If you make one of them, you just lose. Not that the problem is difficult. The main idea is already done. But yeah, so okay, 13. Does anyone have objection? I think this is like a court at this point. Does anyone have any objection to 1386? Please don't tell me it's divisible by 7. Q is 13, it's prime. Thank God, it doesn't have factors. So, better be correct at this point. Right? Okay. Alright, so 23. Yeah, too many traps in this question. Alright, problem number 23. Somebody asked me, hopefully that person is around. Consider the 14 numbers 1 power 4, 2 power 4 up to 14 power 4. The smallest natural number n such that they leave distinct reminders when divided by n is. Okay. So you want k power 14 and k power 4 and you want them to leave distinct reminders and divided by n. Obviously you should cross 14, that's for sure, right? What I mean, I think k power 4 should not equal L power 4, right? So when does k power 4 equal L power 4? Modulo n is the question. When does this happen? They leave distinct reminders. So this should have, the only solution for this is k equal to L, which means you should factorize, I think that's all. K square plus L square into k minus L into k plus L is equal to 0 mod n. Basically you should have n such that you don't have any k plus L is 0 mod n. Like if you have 15, if you take 15, for example, n is 14 even, then obviously you can take plus or minus 1. So 14 will not work, right? Because plus 1 power 4 is minus 1 power 4. 1 plus 1 is 0. I mean 1 plus minus 1 is 0 mod 4. 14. So 14 is not a good idea, I guess. 15 also you can't take, because if you take 15, modulo 15, you have things like 14 plus 1 is 15. 14, does 14 work actually? Sorry, 14 doesn't work, right? 14 doesn't work. 2 and 12 you have, which add up to 14. So you want to go beyond, like, you want to go beyond, I guess, 28 or something, 29, because or else you can always find something that will add up. Then also k square plus L square should not be 0 mod n. So I think the number is right. I think we have done 9th. Some people are asking 9th. Just a minute. Let me just see what is 9th. 9th we did, no, 48. It's there, I think, if you go back to the discussion. Okay, so let's come back to this. This question looks interesting. What is k plus L is 0 mod n? What does that mean? K is equal to minus L mod n. K equal to minus L mod n should not have a solution. So k plus L, if it's less than n, we will be in trouble. So k plus L, you should find a k and L. When will this happen though? Yeah, k plus L cannot be 0 mod n. You can always find one. No, you cannot. Once you cross 28, you can't, right? Because if you are at 28, at n equal to 28 already, you cannot have k plus L is 0 mod n, correct? No amount of 1 to 14, if you add two numbers, it will be 0 mod, two distinct numbers will be 0 mod 28. So 28, you cannot have this solution. Great. But what about k square plus L square though? K square plus L square can be 0 mod n in 28. So when you square numbers, this, what does that mean? It means k square is minus L square. So x square is congruent to minus 1 mod if we could divide by L, n. If you divide by L, k by L the whole square minus 1. So k by L 21. Krishnakant saying 21 connect to Ri. Okay, so we have not checked 21. So because somebody asked us to do 23, we are doing 23. We'll come to 21. Okay, but this is interesting. K square plus L square is 0 mod n. So what can happen there? 29, is 29 the solution? 28, can it happen? K square plus L square? I think 28 is the smallest. Okay, first of all, it should be at least 28 so that this condition holds. So let's try 28 only. What will happen if you do 28? Modulo 28 can sum to equal. So 1 square plus 2 square or something like 2 square is 4. 2 square is 4. What are all the squares modulo 28? Maybe that's the point. 0, 1, 2, 3. Only half you have to try, but that's quite a big number already. But let's try it. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. and if you square it, you'll get 0, 1, 4, 9, 16, 25, which is minus 3, 36 is 8, 49, you guys should help me, is 21 maybe. Sorry, how much is 49 modulo 28? 21, yeah, minus 7. 8 square is 64, 28 is 56. Oh, what? Did I make a mistake? 36 is 8 mod 28. Oh, 28 is not prime, that's why. Oh, already, I mean, if you're not prime, you're already in trouble, right? If you're 28, 36 is also 8 mod 28. And yeah, sad story. 64 is also 8 mod 28, I think. Yeah, not being prime is a problem. Okay, so which means we can try 29 next. I think 29 should do. It's most likely 29. 29 is a prime, and prime numbers are generally nice. I'm assuming it's 29. So 29 won't have this issue, first of all. So 29 is prime number. So which means if product is 0, then one of them has to be 0. So if you just made this, we have made sure is not 0. So we just have to worry about k square plus l square now. So 0, 1, 4, 9, 16, 25 is minus 4, 36, this is minus 4, 6 square is 36. 36 is how much mod 29? 36 minus 7, right? So 7. 49 is 20 mod, and 64 is 29 twos is how much? 57. 64, 7. Oops, why am I getting it wrong? How much is 64? It's 8, no? 8 mod, I think. No. How much is 64 mod 29? 29 twos is, no, 29 twos is 58. Okay, 58 and 6. Thank God. That's what it cannot be. I know for a fact. Cannot repeat. Okay, so 6 and 81. How much is, I think you guys will have to help me here. 81 is how much mod 29? 29 threes are 33s is 90 and 87. Okay, so minus 6. And 100 is 29 into 4, 36, 3, 4 2s are 8, 9, 10, 11, 116. So 29 4s is 116. So 116 is minus 16. And so on. So by the way, already are we in trouble? By the way, there is 16 and minus 16, no? 6 and minus 6, we are in trouble already. So 6 plus 6 will be 0, so we are done. It's gone. So 8 power 4 is 9 power 4 modulo 29. We don't even have to do the remaining calculation. So already here we were in trouble. 4, already here we were in trouble. We should not have calculated anything. So Krishnakant is saying somebody, Prashant Jain is saying 96. Yeah, I mean, maybe he's right. Is he right? I'll come back to that. I'll come back to that, Krishna. I'll explain to you in a couple of minutes. Just wait. Just let me finish this off. So 29 is not working already. So what is the main thing? I mean, if I do it by brute force, I feel it will take a long time. I have to figure out exactly how k square plus l square equal to 0 mod that number, most likely prime, like say 31 maybe, will not work. Like there's no solution to x square plus l square. How can there be a solution to this? This is actually tricky. How did you guys solve it? Just a minute. K square plus L square is 0 mod P. When does that have a solution? That solution, if it exists, should not be less than 14. I mean, both of the solutions, I mean, if one of the solution is less than 14, the other one must be larger. Somehow like that I have to find. How do I do that? Tricky. K square plus L square is 0 mod P. Certainly bigger than 28 for sure. Can I say more? Should all be distinct. How do I do this? How do I do this? K square plus L square is 0 mod n 1 square plus I don't know. I mean, the point is, I think the point is the quadratic equation, but that's not that helpful actually. K square is congruent to minus L square mod. If you have a prime of the form 4k plus 3, is 31 of the form 4k plus 3? I think so, right? 31 has no solution for k square plus L square is equal to 0, I think. Correct? What is the reason? Correct. K square, if you have sum of two squares, if you write any natural number as sum of two squares, then that number cannot be divisible by 4k plus 3, I think. Right? 29, it can of course be written as 25 plus 4 already, right? So is that enough? Can I just argue that there can never be any way a solution for k square plus L square is 0 mod 31? 31 cannot divide. Is that true? But is that true? I'm trying to recall. This is a theorem, right? How did we? Let me try to recall what I'm trying to say. Am I making sense? K square plus L square is if you have sum of two squares, n, can I argue that any prime of the form 4k plus 3 cannot divide? Any prime of the form 4 cube, whatever, 3 mod 4 cannot divide this. Because if it did mod p, and p is of the form 4k plus 3, then it would mean that you can write, I mean not 4k, I mean k dash, whatever, because already k I've used, minus L square mod p, and this will k by L square is minus 1 mod p. You can divide by L, I mean, because it's modulo p, right? All non-zero numbers are invertible. So you'll get a solution to x square minus 1 mod p. Now p is even, so you can raise it to the power p minus 1. So you'll get x power p minus 1 by 2. Raise it to the power minus 1 power p minus 1 by 2. But p minus 1 by 2 is an odd number. Right? Is that contradicting something? 2 power 2k dash plus 1 is minus 1 mod p. And because of which on this side it's x power p minus 1. But x power p minus 1 is minus 1 power p contradicts Fermat's-Little theorem. Okay, so therefore you cannot have, correct, you cannot have k square plus L square be 0 mod p if p is of the form 4k plus 3, and the nearest, I mean already 29 fails, so the nearest one is 30 will not work because it's even, so some 2 will repeat, we can check that if you want. So the next one is 31. So 31, see, it's a, if I go modulo prime, product of 3 numbers is 0, means each one of them should be 0. K plus L cannot be 0 because, you know, sum cannot add up to 31. For numbers from 1 to 14, any 2 if you add, it won't add up to 31 for sure, any 2 distinct numbers. So this can't be 0. And just now I argued k square plus L square can't be 0 mod p. So therefore k must equal L. So if k power L is 4 is equal to L power 4, k equal to L, that means they are all distinct. They cannot, for two different values it cannot happen. So n is actually 31. Nice, got it. Okay. Alright, so alright, so I don't know if people are around anymore, but let's solve 21, which Krishnakant asked. Alright, let's try. So an integer n is such that floor of n by 9 is a 3-digit number with equal digits, and n minus 172 by 4 is a 4-digit number with 2024 in some order. What is the remainder when n is divided by 100? Integer n is such that n by 9 is a 3-digit number with equal digits. Okay, and n minus 172 by 4 is a 4-digit number with digits 2024 in some order. What does that mean? What does this mean? So if you have a number line n by 9, some fraction, and why 172 though? 4 4s are 16 4s. Okay, so n by 4 minus 4 4s are 16, 12 4. Okay, greatest function n by 4 minus 43 is a 4-digit number with digits in some order. N by 9 is a 3-digit number with equal digits. If it's equal digits, let's say the equal digit is d, then it will be d plus 10d plus 100d, so d into 111 divided by 9. It will be a number of that type. That's what n is, right? So n is d into 111. This, oh sorry, the number that is after that is of the thing. Okay, fine. So floor of n by 9 is d into 100. So what does that mean? It means if I divide n by 9, 9q plus r, if I write, if I divide n by 9, then the floor of 9 is q. So q, the quotient is number of the form d into 11. So 9d into 999. Okay, so which means we have a nice form for it, right? So the number n is 999d plus mix q is d into 111. So r, it's of this form. Then you plug that in here. Some ugly thing. Okay, so 999d plus r by 4 minus 43. This is in some order, is a 4-digit number, so 0 doesn't appear, 2024 in some order. Okay, then what is the remainder when, okay, so it looks like there's only one such number or something, because what they say, what is the remainder when, or at least the last 2 digits are the same for if there are multiple answers, because they haven't, sounds like as if there's only one answer, at least for the whole problem. So maths 4372 says, sir, take floor n by 9 to be 999, it is satisfied. N by 9 to be 999, it satisfies it, is it? N by 9 is 999, let's see. So then n is 9 into 999 minus 172. This somehow works. This gives you 2024 in some order. Okay, that's a miracle. So 9998, how much is 9 into 999? So it's 99 is 81, 99 is 81, 89, 99 is 81, 89 minus 172. So 11, 8, 1 and 8, 8. Okay, so 8819 by 4 is 4 2s are 8, 4 2s are 8, 4 0 4. Oh, I see, it does. Okay. Alright, so you're right. So this question was like, just try the best possible one, it works. Okay, it does work, that's correct. So n is just 999 into 9, and you, if you multiply, you get 8991, and if you divide by 100, the answer is 91. Yes, I think that's what somebody said. So Wilma Fernandez says the minimum value of n is 2024 into 4 plus 172. Well, I was going backwards here actually, trying to see what are all possible values of this. I think you can get past it very quickly by just plugging in values directly, 999. But let me just continue with this line of thought. 999 d plus r by 4 minus 43 is 2024 in some order. 998 is divisible by 4? No, 996, okay. Oh, I'm just trying to see if there was a way to get this answer by really working it out. 4 2s are 8, 19, 4 4s are 16, 39, 4 7s are 28. So 4 into 247, 4 2s are 8, correct, no? 4 4s are 16, 39, 4 9s are 36, sorry, 4 9s are 36. Four 9s are 36 plus 3d by 4 minus 43 floor. This is 202r in some order. So it's like 206 plus 3d plus r by 4 floor is 2024 in some order. D, since D, it's a 3-digit number, D can be any one of the digits. Oh, okay. So actually you can, okay, you're done, because you can sort of directly play around with different values of D here, right? That's it. So essentially D can only be between 1 to 9, right? Because notice n by 9 is like D into 111, it should be a 3-digit number, which means D must be a digit from 1 to 9, right? So you have only options from 1 to 9 to try actually here, essentially, to see what gives you, and r anyway in each of the cases, we know r is anyway between 0 to 9. So in principle one can do it by brute force, I think, that is the point. Although as the solution somebody noted that n by 9 you can just put 999. Yeah, okay, so the answer is 91 for this one. I'll assume you can do by trial and error, finish it off. Okay, which other problem? So I think we were doing some other problem. I think Krishnakant in chat had said Prashant Jain was saying 96 for this problem, problem number, maybe he's right, for problem number 9. I think it's 48, because I think like they have said in this problem, we say a pair of points, flower bracket. You see, flower bracket would mean that, at least my take on the matter is like, flower bracket would mean that these two are, you know, it's not an ordered pair. Like in other words, if you count, so for example, 0 comma 0 and 2 comma 1, 0 comma 0 and 2 comma 1 is the same as 2 comma 1 and 0 comma 0. That's what this flower bracket means. So that's why I was wondering whether maybe it is. So if you choose 6 choices here and one of the 8 choices here, you will get one pair. Similarly here also you'll get 8 and 6. But basically you are always double counting essentially. So whenever some pair like this is possible, the opposite pair is also possible. Okay, and that's counted separately. So that is why I think it's totally, if you calculate 48 plus 48, it looks like, but then because of the flower bracket, I think it's just half of the solution. Alright, so somebody is asking what? No, so we are just solving it on the spot. So people who are just looking at what's going on, I mean, I have not solved this paper, so I'm solving it on the spot. So if somebody demands me to solve some problem, I do it. So somebody is asking, Fiery is asking, what is the answer to question 20? I don't know what the answer is. I've not solved it yet. So if I've solved it, I'll tell you. If not, I'll solve it now. Okay. So in a few minutes, you will know. Let's just try this. So okay. On a natural number n, you are allowed two operations. Multiply n by 2, subtract 3 from n. For example, starting from 8, you can reach 13 as follows. Multiply by 2 and then subtract 3. You need 2 steps and you cannot do it less than 2 steps. Starting from 11, what is the least number of steps required to reach 121? Okay. 11 to 121. And what can you do at every step? You can multiply n by 2 or you can subtract 3. So you can start with n. So n goes to either 2n or it goes to n minus 3. That is the rule. Okay. So what is the least number of steps required? Let me think. So I mean, obviously we can try to keep doubling. I think the basic strategy is because doubling exponentially grows, whereas subtracting 3 goes linearly, and you can only go down from it. So the basic strategy that anyone will try, most likely, although that might fail, just the first thing you will try is to keep doubling until you reach close to what you want, and then you start subtracting and hope things you can reach, right? That's the plan. So you can, right, so Anudip is saying that you can basically try to go backwards, right? So what does going backwards mean? So going backwards would mean 121 plus, I see. So I think it depends. So 121, the point is that to divide by 2, whenever you could, I think going backwards, Anudip's point is that you can, it will tell you when you can divide by 2. This is 121, you can't really divide by 2 at this point, right? So the reverse steps are dividing by 2 and adding 3. So 124, so I think that's Anudip's point. So it will tell you exactly when, so maybe that will give you the best possibility. So you divide by 2, 62, then you divide by 2, 31, then you add 3, 34, then you divide by 2, 17, then you add 3, 20, then you divide by 2, 10, but I mean you should reach 11 though. So maybe it was not a good idea. So if you could reach 22 faster somehow, okay, I don't know. So if you go to 5 now, then you can add 3 and then add 3, right? So but this will give you how many steps? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Question is, can you beat 10 steps? Okay, can you beat 10 steps is the question. How do you decide what is the minimum number of steps that you could do? You can you do it by generating functions or something? Again, can we, but how will you double though? Generating functions, q of t square, q of multiply by t cube, divide by t cube. So how do you go backwards? What does it mean that you did it less than 10 steps? 121. What are the other things you could have done? I guess here you should ask yourself that. So can we argue it will only increase the number of steps? If you are at 121 and you added 3 here, that's what we did, but you can't divide by 2 anyway, so this is your first here. But at this point you could have added 3 more, right? What stopped us from that? So What if I added 3? What, it would have been worse, right? Can we argue that? So obviously you have to add once more, or else you can't divide by 2. So 130. Now if you divide by 2, what will happen? 65, 68, divide by 2. Maybe it's if you can get too close to a power of 2, it will like sort of, you know, reduce the steps drastically. So from 3, is there some closest power of 2 that you can reach very quickly? Oh no, but you need to reach 11, right? Yeah, then I don't know. So 2 3s are 6, 2 9, 2 4s are 8, 17, and 17, that's the problem. I can only add 3, 20, reach 10 again. Once I reach 10 again, I know that I can do it in 3 steps. So 3 4 5 4 5 6 7 8 9 10 11 12. Yeah, it's only more. Maybe it's 10, but that's trial and error. How does one prove? So yeah, but how does one prove 10 is the optimal? Adi is asking, is a score of 60 safe? I have not solved the whole paper, but the paper seems pretty easy actually. But I think it will be definitely above 40, somewhere between 40 and 50 is what I'm guessing. But I have not solved all the questions actually. Maybe only the first few questions were too easy and the rest were very hard. Maybe, who knows? I don't know. Some of the questions were nice though, right? Like this 21 was nice, direct trial, as I think maths 4372 noted. This problem was very nice. I like 23. It was nice. But I have not tried the others, so I'm slowly trying one by one. So let's come back to this problem. So 10 I seem to be getting, but how do I prove 10 is optimal? Why can't I do it in 9 steps? Why? Is there some, how does one prove you can't do it in 9 steps? I think subtracting 3 and doubling. Can you do it by binary or something? Is it some binary trick? Subtracting 3. Subtracting 3 is like subtracting 2 then subtracting 1, but yeah, you can't do it in, you have to do it in 1 unit. Can you do some binary thing, like if you write it in binary, then something will happen, and doubling will mean adding, subtracting. Maybe it is binary. Okay, so is it that if you 11 can be written binary as 1 plus, 8 plus 2 plus 1, right? Like this. And 121 can be written as 121 is square of this. So it's essentially, what is 121? 121 is pretty big to write. So how do you write 121? You take the nearest power of 2, that is 64. Then you have 36 plus 21, which is 57. So then you keep adding all, okay, so 32 plus 16, I guess, plus 8. I think 32 plus 16 is 42, 48. 60 plus 40 is 100, 112. 112 plus 8 is, and then 1. Okay, I guess this is what am I so hoping it's correct. 8 plus 8 is 40, 104, 120, 121, correct, I think. So 1, what's that in digits? 2, 4, 8, 16, 32, 64. Okay. So is that helping? So I think because when you're doubling, you're like sort of like adding a 0. That's the move, binary wise. But when you're subtracting, you are, if you want to go from here to here in minimum number of steps, reverse, let's say, as we were going, then what can you do? You can either add 3 to it, which is 1 1 to it, or you can, if there's a 0 at the end, you can divide, remove the 0. we have to argue that if you have to prove it, then you have to argue that whenever you see a 0, it's greedy. The greedy algorithm of just cutting the 0 is always definitively better than doing anything else at that point. That one thing we have to prove. That is, if you are at any situation, okay, and you have a 0 at the end at any point in that number, at that point you have two possibilities. You can divide by 2, that is, when you are going backwards you can divide by 2, that's cut off the 0, okay, or you can add 3, right, you can add 3 to it. But if you add 3 to it and you add another 3 to, obviously the next thing you can only do is add another 3 to it, because you can't divide by 2 anymore. So if you add 2 3s to it, you'll add a 6 to it, and 6 is like 110. So you can either add 11 or 110. If you add 110 and then you divide, then the number of steps will only grow larger. Can we argue that somehow? Well, the number will grow larger than this directly dividing by 2, but does that mean, can't tell. How do I argue the greedy algorithm is better? Of whenever you see 0, cut off 0. To argue that any other strategy is worse, right? Oh, are you guys able to see the stream? Sorry. Are you able to see the stream? How do you do this? How do you look at, I think this kind of question was there, no? This kind of question was recently there in some US exam, some Harvard math tournament or something. But how did you prove? There also I didn't prove it, I think. How does one show anything here? If you have subtract 3, I would have marked 10 in the exam, but I'm worried here. How do you prove it's greedy? Greedy algorithm is the best. Maybe you argue by induction or something that if n is larger, no, that's not true, right? That's not true. To go to 22, you take only one step from 11, but to go to, I don't know, 17 or something, you have to take way more steps. So it can't be, it's not. Keep doubling, you'll go very fast, you'll cross. What is the problem with doubling very fast? So if you double 11 into 2 square 2 cube 8 2 power 4 and 160 16 and 176 you reach, and then subtracting is too much of a pain, I see. So you just subtract in multiples of 3, 55, close to 55. That you may not even be able to do it. Okay, I see. So I think we should be able to create some technique to do this. Every xn is either 2 times xn minus 1 or xn minus 1 minus 3. So the fact that there's an OR option, we should make it into some generating function choice or something. Like, it's like t into 2t plus multiply xn minus 1 with 2, or you subtract 3. a bit of a problem. So subtracting 3 is a bit of a problem. How do I write it as generating function wise? I want to come up with some way to solve these kind of problems where we have a proper proof without jumping. Adi saying Ali Sharin also got 10, but did Rijul prove this minimum, Adi? How did he prove it? Okay, so for now I'll put 10, but I'm not happy. Unhappy 10. What's the proof? We need proof, right? Okay, but somebody else was asking some other question. Let's see. So, who is question 30 card 24? Shivani was asking question 30. Right, before that somebody else was asking something else, no? 21 we did already, 18 we have done, right? 13 was the answer. 28. By the way, we had done 23 also. Nice question, I love it. It's very nice. 28. Did someone ask 28? Okay, find the largest natural positive integer n such that 1/2 of n power 8 plus 3n power 4 minus 4 is not divisible by square of any prime number. Okay. So Scorpion Boy says is 23 a good score? Okay, not sure. I think I'm suspecting the cutoff will be about 30 if the paper is easy enough. I mean, if there are some of these questions which, by the way, if I might take long because I like to prove everything I write, but as much as possible. But you can sort of guess one standard strategy in many of these problems, and like here as noted by someone in chat that you can directly try 999. Here you can do trial and error and do the best possible thing. You will get 10. There are lots of these standard kind of tricks. Here there are some trap questions which people can fall for. So overall, I think I've not solved all the problems. I've solved like hardly around 10-15. But it looks like the initial 2 markers were very easy, like a little too easy. So I think if you have like the first 10 questions are too easy. I didn't try the remaining here. Maybe I should try in order. So to see, people are asking. So I've not solved a single geometry yet actually. So maybe the geometry questions are hard, but it looks like it will be about 30. Cutoff will be about 30 is my guess if it goes on like this. I just went directly to harder problems. Okay, let's see. Let's see 11. So Vima Fernandez is saying the cutoff will be 40 to 50. I said it will above 30. 40 is above 30, right? I didn't say it is 30. So the cutoff is above 30 for sure, 100% is what I think. But it could be 40. I'll only know if I solve the whole paper. Okay, even 30 I'm not sure actually. I have to finish solving a few 3 markers. But it looks like, because the 2 markers were too easy. The positive real numbers ABC satisfy some number. So geometry was easiest. Oh, okay. So maybe we'll try solve 12 then. Okay, consider the square ABCD of side length 16. Let E, FP points on CD such that CE equal to EF equal to FD. Okay, so let's solve it. Let's see, square ABCD. Let E and F be points on CD so that CE is equal to EF is equal to FD. Array? Okay, haven't we done some problem like this? CE is equal to EF equal to FD. Okay, let the line BF and AE meet at M. Yeah, okay, it's becoming more and more problem we solved recently. So, okay, area of triangle MAB is what? What's going on? it's similar, no? These two are similar, and we can calculate the ratio. So what is the fastest way to do this? So let's see, 16 by 3. What do we know? We know this, each one is 16 by 3, and this is 16, this side. So this is 1/3 of this fellow, right? So if this area is A, this is A by 9, and these two are equal by symmetry. And let's see, what other things do we know? What is the problem here? So what is the relation between these two areas? That's all I need to know actually. So what is this area? What's the problem here? This area we can know also, I think, right? This also we know. So we're done. We can calculate the remaining, I think. So we know this area. Let's see. Maybe it's not that bad. So we know the full FCB area, and that's correct. But the problem is then we don't know where this cuts, right? Just a minute, I'm thinking. So then this plus this minus A by 9. So 2 into FCB area minus is this area. Then we are done. We can calculate, I think, right? So let's see. So 2 into FCB area is, let's calculate FCB, half into 16 square by 3, that is FCB area. And if you do 2 times FCB, you will get 16 square by 3. This is 16 square by 3 minus A by 9, because it has counted A by 9 twice. So minus A by 9. This triangle piece got counted twice. So now we have computed the sum of these three plus A. Okay, my 9 and A look alike, but this is A. A is my area of the inner square, and this is equal to whatever overall area, 16 square. So you can solve now, right? 8A by 9 is 16 square into 2 by 3. 3 3s are 16. 8 2s are, and A is, I don't know, some, wait, why is area not a natural number? Did I make a mistake again? A is 6 into 2 into 16. No, it is a natural number. Wait, I thought the answers were all 2-digit numbers. Side length is 16, yeah, not area. Okay, so that's it, right? So I hope I have not done any mistakes. So this is 16 by 3, you divide into 3 equal parts. So this entire, oh, it's 2 into 16 by 3. Did I make a mistake there? No. Is that the problem? Half into, I think I might have made a mistake there. So half into 2 into 16 by 3 divide into 16. That was this. And then you multiply it by 2. So it's 2 into 16 square by 3. Yeah, okay, fine. 2 into 16 square by 3. I make lots of calculation mistakes. So 8A by 9 is 16 square by 3. 16, 3, 3, 8, 2. Okay, so 3 into 2 into 16. Habba. 6 into 16. Okay, now it's 96. I think. Yeah, answer is 96. Done. Okay, but 11 we didn't do, 10 we did. So let's do 11, looks nice. Positive real numbers A, B, C, sorry, if the mic made some noise, I apologize. So the positive real numbers A, B, C has A by 2B plus 1, plus 2B by 3C plus 1, plus 3C by A plus 1 is 1, and 1 by A plus 1, 1 by 2B plus 1, and 1 by 3C plus 1 is 2. Then what can you say about some other blah blah blah? Okay, so what is the point of this? So how can you get what A is? Maybe you can do some subtraction or something and you'll get it. Let's see. So I think it's one of those, if you put 1 by A plus 1 as a variable, you'll get it kind of a thing. X 1 by, let me try 2B plus 1 is Y, and 1 by 3c plus 1 is z or something, and basically I'm guessing, let's see, 1 by x minus 1 into 2b plus 1, which is y, plus the first equation I'm writing now, 1 by 3c plus 1 is z into 2b, which is 1 by y minus 1. It's exactly that, it's 3c only. Okay, so I think it will work. I'm hopeful. Let's see. A plus 1 is x into 3c. 3c is 1 by z minus 1. 1 by z is like 3c plus 1, 3c plus 1 minus 1, right? So this is 1. So you have y by x plus z by y plus x by z minus x minus y minus z is equal to 1. What do we want? We want 1 by y minus 1 by 2. We want 1 by x minus 1 plus 1 by y. I think it's too much to do this, is it? 1 by a. Can we sort of guess an answer here or something? How do I get this? So should I? No, I think there should be a 11 is too simple. Okay, so Durba is saying 11 is too simple. Okay, so let's see. Oh, you can guess a solution or something like that? Is that what you mean? Like, you can plug in a value or something like that. A plus 1. Or if you add, I would like a plus 1 by a plus 1 to 1 by a I want. AB plus BC plus CA. Well, that a by 2b plus 1 is no. I've seen this kind of question before. X by y plus 1. It's like that 2b is just y and wait a minute. What is the problem? I think I should have gone along my strategy, not ditched it halfway through. 1 by x minus 1. Maybe I should have chosen some other variables then. Just let me see. 3c plus 1 minus 1. If I do, what will I get? 2b plus 1 minus 1 if I do. I see. But that won't help, I think, right? A plus 1 minus 1. The first equation. That will give me 3. I think they are positive real numbers. So one thing is by inequalities. One thing to try is inequalities when, does that work? Okay, so maybe it's some inequality situation. Just a minute. If it is inequality, I can make a reverse guess. What Cauchy-Schwarz or something? What is it? Some A to B. What is this? I'm sorry. What is this? Equal to 2b equal to 3c. X by x plus 1 half. X is half. Is it a equal to 2b equal to 3c equal to half works? Something like this. Because if a is half and 2b is also half, half by 1 plus half is 1 by 3. So 1 by 3 plus 1 by 3 plus 1 by 3 is 1. And a plus 1 would be half, 1 by 3 by 2. 2 by 3 plus 2 by 3 plus 2 by 3 is 2. Correct, it satisfies. Okay. So I mean I can guess the answer. 2b, I mean it just satisfies. B is equal to 1 by 4, 4 and c is equal to 6. 1 by c is equal. So I think answer is 12. Yeah. Okay. I think okay. So my guess is because I wanted to use some equality case of inequalities. Basically positive real numbers, right? So this is a hint in Olympiad problems that when they say positive real numbers, maybe you want to use inequalities. And in inequalities, the equality case is what I wanted all these things to be equal, and all these also to be equal. That forced a equal to 2b equal to 3c. So if a equal to 2b equal to 3c, that will happen. Then I plugged in a equal to 2b equal to 3c and solved for when it's equal, and I got a equal to 2b equal to 3c equal to half. So it does satisfy. So anyway, in this question, as long as one solution you get, you are done, right? So you can always say directly now a equal to 2b equal to 3c equal to half will satisfy both first equation and the second equation. So solve for ABC and get it. But that's a cheating answer, because in other words, yeah, fine, you can get it in IOQM. You should do it in IOQM that way. Okay. However, of course, we are here to learn right now after the exam. So I am here at least to learn and figure out. So I want to know why. So in other words, I think the equality case of inequality this is. So I have to somehow, I want to prove some kind of an inequality actually. Most likely it is some, which inequality is this? It looks like some Cauchy-Schwarz maybe, but Cauchy-Schwarz, it's Cauchy-Schwarz, then it will be okay, it looks like some then AMGM or something where equality cases expressions are equal. I guess, or it can be rearrangement also. If A is greater than or equal to 2B is greater than or equal to 3C, order A, 2B, 3C in some. Actually, it doesn't matter. 2B you can call it Y and 3C you can call it Z and A as X. Really, just that they have just chosen that variables that way. So if you choose A to be greater than or equal to 3C, then I think you can do it via, can you do some can you do then A plus 1 is greater than or equal to, I think you can do rearrangement inequality. Why not use this opportunity to learn a new inequality, right? So then 3c plus 1, 1 by 3c plus 1 is greater than or equal to 1 by 2b plus 1 is greater than or equal to 1 by a plus 1. And by rearrangement inequality, a by 3c, oh, I think I have to order it slightly differently. A by 2b plus 1 is there. So 3c plus 1 should be in the middle. Okay. So let's just change this to 3c to b. I'm just trying to see if I can bring it to that form. 3c to b, 3c to b, and so now can I do? Yeah. Now by rearrangement inequality says if you have two positive sequence of positive numbers which are decreasing like this one and this one, then if you pair the largest with the largest and multiply, that will be the largest possible value, right? So I'm just trying to see if I can get something out of it. I don't know. Okay, it looks similar, that's why. But it won't give. Can't use rearrangement here. Okay. So any other way of grouping will give you only lesser. So a by 2b plus 1, it's 1. So it won't contradict, I think. 2 by 3c plus 1, 3c by a plus 1 is less than or equal to the best way of grouping, that is a by, I think I should have done a by a plus 1, a by 2b plus 1 plus, but 3c by 3c plus 1. Okay, it's not helpful. So this is 1. I wanted to use this. So 1 by a plus 1 I wanted to use here. I think I should have ordered it differently. So 3c plus 1, yeah, there is no way I could have used rearrangement because this is cyclically changing, right? A to b 3c, then a to b 3c. What other way to prove? So I don't know. So AMGM, some AMGM, weighted AMGM. No. How did you guys prove this? In other words, okay, so I think the main question is, yeah, I did equality case only. Oh, hello. So basically, I did the equality case of AMGM, okay, equality case of AMGM, and but I mean, I don't know what's the AMGM. So actually, I don't know that it's AMGM, but I'm like, this must look, equality case is one thing to try. Anyway, they are giving, we can always, if we get one value, we are done in this problem, but actually, it's not a fair thing to solve, right? Like, basically, because you would like to solve, you would like to know why that is the only solution, right? I mean, in the exam you solve, I get it, but here you aren't interested to know why there's only one solution. So 1 by x plus 1, 1 by y plus 1, 1 by z plus 1 is equal to 2, okay. Then it turns out the only possible solution is x equal to y equal to z equal to half, okay. Why? What is the case? So we have to do some AMGM inequality, but how will we take? I think we need to put a constraint. What constraint will I put? I think I can use 1 by x plus 1, 1 by y plus 1, 1 by z plus 1, and then I can bound. Like, I think I did that earlier actually. Call this A, call this like A, B, C, and then try to write this, and then try to show that this is the equality case of AMGM. It will hold with inequality. Maybe that's the proof. Let's call this A, call this B, and call this C. So then you have a sum constraint on ABC, maybe. I don't know, I'm just trying. So we already solved it, but just at least got the answer for IOQM, but I'm still very interested to know how come that's the only solution. So I'm very curious. So x is 1 by, yeah, so what I did earlier basically. So b into 1 by a minus 1 plus 1 by z plus 1 is c into y. Y is essentially 1 by b minus 1, right? Because 1 by y plus 1 is b, so if you rearrange, you'll see that y is 1 by b minus 1. And this is a into, I guess it's a, yeah. So 1 by c minus 1. So if you could prove this equality holds, it's really an inequality of some AMGM or something, and equality holds if and only if things are equal, then we are sort of done. So then all of 1 by x plus 1, 1 by y plus 1, 1 by z plus 1 must be equal, ABC must be equal, so each one must be 2 by 3, and then you solve for it and get x is half. So that's the plan. So I don't know how good that plan is. C by b plus a by c is equal to 1 plus, oh, a plus b plus c, which is, wow, nice. 1, a plus b plus c is 2, so 1 plus 2 is 3. Done, right? Done. Awesome. Brilliant. Okay, done. B by a plus c by b plus a by c is greater than or equal to 3 by AMGM. But therefore, a by b equal to, so equality case is when b by a equal to c by b is equal to a by c, which means c square is equal to ab, b square is equal to ac, and a square is equal to bc, which should mean if you multiply it throughout, abc is equal to, so I think from there we will get a equal to b equal to c. Okay, do we get actually? So if you multiply it out, you will get, you will not get anything new. So if, I think we still need to prove, right, y equal to b equal to c. You can subtract. So c square minus b square is equal to a into b minus c. So if b is not equal to c, then c plus b will equal minus a, but that's not allowed. So c must equal b, and b must, similarly you can plug it back in and get. So once c is equal to b, the ratio is 1 and a is equal to c, so a equal to b equal to c. So all of them are 2 by 3. If a is, all of them are 2 by 3, then in the reciprocal below, x plus 1 is 3 by 2, y plus 1 is 3 by 2, z plus 1 is 3 by 2. So x is, y is, z is half. Done. Okay. All right. So yeah. So AMGM. So wait, Abhi said something. Equality AMGM case. It's correct, no? So AMGM is what we used, B by A, C by B and A by C. Nice. All right, 13th problem. Codit now was asking what's cutoff for Delhi, no idea. Okay, so just let's quickly, because people are asking for cutoffs, just let's quickly note what are like really easy problems, right? So let's mark it in pink. So this is very easy, maybe let's mark it in things you can see. So very easy, E, this is very easy, this, all these things are very easy actually, too easy. This is a little, well, not very, I guess. So this is E, easy. This also, this is very easy. This one required a little bit of thought, but you could guess it. I mean, if you were, if you're careful and you think a lot about being then it's one thing. But if you sort of intuitively believe it and tick, then problem 8 you will tick. 9th one also I think is doable. 10th one was very direct. 11th one again, you can just guess by a little bit of trial and error, but of course you have to notice that you have to assume A equal to B equal to 3. So it's not so easy, simple. This one was direct again, just basic similarity and area calculation, but not easy to the extent of the first few problems, just like trivial like the first 2-3 problems. But these were all I think doable, so I think many people will get it, at least the ones who are preparing for Olympiad seriously. Okay, what about, okay, so by the way, we also have done some harder problems. So because some people in the chat demanded, they wanted to know how to solve it, so I solved it for them. So coming back to that question, this question was easy, but it has a lot of traps, lots of traps. I mean, at least we ourselves fell into some of them. And yeah, just for the trap, actually the technique is not too difficult, it's standard number theory, but again it's not easy obviously, but certainly doable. But I think just because of the trap many people might not get the answer. It's possible. I'm still not sure if this answer is 13, but I think it's correct hopefully at this point. So I think I would say this problem is like medium, and in some sense medium simply because of the traps, or else it's on the easier side. This is problem number 18. Okay, problem number 20. Well, problem number 20, most people will just do it by guessing. So it's essentially on the easier side because people are not going to try to prove 10. I still don't know how to prove 10 is the minimum. Okay, you go backwards and you do the greedy algorithm basically. Okay, you'll have to prove that the greedy algorithm is the best, but how do you prove it? So I would say this again is on the easier side. Okay, easier because most people are just going to, if you are going to just say try it, go backwards and calculate. And you've seen these kind of questions before, it's not like new, it's sort of standard. 21 is also on the easier side because if you do trial and error with the best possible thing, it will work. If not, even if you can do a small analysis, it will work. Okay. However, 23 was fun. My most favorite question was 23. It used quite a bit of fun number theory. So I'm not sure whether people will get this one. This one I would say is on the harder side, but still easier, on the easier side of hard, I think, because in the worst case, just to note, once you realize that you need at least 28 here, you can just do trial and error and try with the like 29 and 30. It won't work. You just have to trial and error raised to the power 4 and check, right? And with 31, you will see they are different. So once you check these 14 numbers with 31, just by brute force trial and error you can do. So that's why I still think it's not hard. Again, I will say it's on the medium side actually. Maybe on the harder side of medium, maybe, but still on the medium side. Though because medium only because would you note? Yeah, I think. Yeah, I don't think so. Would you note that you have to break it up like this and check k plus l is divisible or k square plus l square is 0 mod n. Yeah, so this is on the medium side. Okay. So obviously, like at this rate, the cutoff will be 80. No, I don't think it will be 80. There are some tricky ones right in between. So up to now it is fine, but maybe there will be harder problems now. And even see here also this problem is medium side. Many people get it wrong. Yeah, this and this I think this is hit or miss. If you either you will take a lot of time and get the answer, or you will just try 999 directly and get it. the idea of trying the largest possible value first and few numbers around it is like a strategy which many people use in IOQM. So this problem I'm not expecting many people to get. But people who really got that trick that it should be at least 28, I think will get it. Okay, so let's go back now. Oops. Okay, let's do problem 13. Maybe now it gets harder, right? 3 positive integers a, b, c with a greater than c satisfy the following equations. AC plus b plus c is equal to bc plus a plus 66 and a plus b plus c is 32. Okay, what is this? So number theory, okay, it's integers and a is greater than c. Okay, all right, find the value of a. We just want to find a. Okay, all right, you have to do some algebra here then, right? Let's see what is the thing. AC plus c plus b minus a minus bc is 66. Does that help? Can you factorize them or something? You can certainly write c into a minus b. Maybe a is greater than c. Should I like a minus c somewhere? Okay, so plus b into, okay, plus b minus a. So b minus a and minus bc ac plus c is 66. So certainly you can write this as a minus b into c minus 1 plus c is 66. This is certainly true, and a plus b plus c is 32. Okay, so basically you can get rid of b if you want in terms of a and c. That's it, is it? Then you just do your usual bounding trick. I think so. Wait a minute, is that it? I mean, because a minus b is 66 minus c by c minus 1, right? So everything became in terms of c on the right hand side. And now b also can be written in terms of a and c, because b is a minus 32 minus a minus c minus 1. So you can bring a to one side and you can put that constraint and we should be done. So 2a minus 32 plus c, you take plus c to the other side, 66 minus c by c minus 1 minus c, right? And yeah, so we are done. So just take 32 to the other side, plus 32, and you divide a by 2. By 2. So you can, if you want, you can call it c minus 32. So by the way, a, b, c are positive integers. So here also you can try trial and error, right? A plus b plus c is 32. So you just need some constraints to try. So a should be very large as possible. Sum should be 32. Of course, the maximum value of a will be, I guess, positive integer. So each one should be at least 1. So a is at least 31, right? No, 30. 30, yeah, at least a is at least 30. So a is at most 30. A is at most 30. Okay, so what is the minimum value of c you can put to maybe make this as large as possible? So you can put c is 2. Will that work? If you put c is 2, 2 minus 1 is 1, 66 minus 2 is 64 by 2 is 32, minus, oh, that won't work, is it? C minus 32 by 2. So it will be minus 30 plus, it will cross, a will cross 50. Okay, so I think a is greater than c, will put a constraint. A is greater than c, will put a constraint. What is that constraint? So for which value of c will it eventually cross is the question. And then that value of a is the answer. You have to do trial and error now, I think. That's it, I think, actually. Right? Yeah, this is what I guess. I think that's what Abhi is also saying in chat. That is a bit easy. You got a is 19. I see. So I think I mean, I think what you guys are saying same as what I'm saying actually, essentially. Like, I think what Abhi has written for a minus b, yeah, I think you've chosen a minus b as one variable, I just written everything in terms of, I got rid of B and I wrote in terms of A and C, and I wrote A in terms of C. So if you all you need is the condition A is greater than C. So now we can do trial and error at this point. So apparently the answer is 19 for A. I don't know, let's see, is it true? Let me finish it off. No? So I'll make lots of mistakes. So just 2C. I hope I don't make mistakes. So first of all, 66 minus C by C minus 1 minus C minus 32 plus 32 minus C, yeah, is greater than 2C, and this is like 3C minus 32 is greater than 66 minus C into C minus 1. So at which value of C will this be true? So it's actually a quadratic expression, so you can keep playing around with there are 32 meaning 30, around 15 you can try. So see extreme cases, it will blow up on the right hand side, it won't work when C is very large. When C is very small, what happens, like 10 or something, 30 minus 30 it will be negative, it will be trivially true. So where does it just cross? 15, 45 minus 32 is 13, 15, 14, 66 minus 15 is 51. This is not true. So essentially when C is, I guess, 10, it was too small. So maybe when C is just crossing 11, C is 11 will work, I think. 66 minus 11 is 55, because 3cc, 33 just crosses 32 when C is 11. When C is 11, 3c minus is just positive. That's one of the constraints, right? So this is 1, and C is, this is 10, so 55 is greater than 10. So C is 10 certainly just crosses, and just before also it does cross. So where does it, so I want C to be as small as possible, right? So if C is larger than 10, also it's trivially true. But when will A be greater than C? That is a question. I hope I've done it correctly. 3C minus 32, yeah. When will C, what happens when C goes too small, by the way? It'll still hold, no? What's the problem with C being 2 or something? C being 2 is also not allowed because A cannot cross 30. So I think there's another bound here. I think it's best to do trial and error actually. If I try to solve these expressions, it will take too long. Because you see there's another bound. That's why you cannot see. This is A, and A is less than 32. So A is greater than C is one bound. Okay. So this expression is greater than C, that will give you this bound, and it is less than 32, which will give you another inequality. So if you try to multiply, you'll get 64. Now I do it the full way, but I think most people would have done it by trial and error, done it really fast. C minus 32. So if you do it the other way, you'll get 32 is, sorry, strictly greater then 66 minus C by C minus 1 minus C. So now if C is too small, this number will be bigger than 32. So you have to find just the correct amount when C, like C, if C is 10 or something, then you'll get 56 by 9 minus 10. So 9, 6 are 54, I think it will cross. So what is the value of C which just crosses 363 by 2 minus 33? So 63, 2 3s are that 31 point something, 31 point, my 29 point something, that crosses actually. So 29, right? So C is equal to 3, it will not be divisible. C is 4. Okay, first of all, you also want C minus 1 into 2 to divide 66 minus C, or else it won't even be an integer, right? So C has to be even here, so that C by 2 is an integer, or at least, okay, that you don't need, but you need this entire thing to be an integer, right? So C is, does it work? C is equal to 3, does it work? 63 by 2, 63 by 4 minus 4 minus 32 is minus 28 by 2. Will this work? No, this won't work. This won't even be an integer. So I think you have to do trial and error. C is equal to 3, C is equal to 4, C is 4, does it work? 62, 6 minus 28 plus 28 by 2. So I think this will not work again. So I think C is 4, 5. I think after a while, even it not being, it being a fraction itself will cut off the answer. So C is 5, will not work. 5, if you have 5, then you'll have 61 by 8. And on the other side, you'll have like something by 2. So that won't work. I think 5, so C is 6 is not working. C is 7. When does this work though? I think you'll have to do too much trial and error. How did you guys find? Okay, was there a shorter way to note? I think I should have taken common denominator and rearranged. Or else you have to still try 30 numbers, right? Isn't it too much trial and error? How do you guys do it without trial and error? Without plugging in values one by one. Trial and error, I mean case by case. How do you solve this entirely? (66C). Is there something I'm missing that can make the calculation faster? Can I write it in some way which makes the calculation faster? That's what I'm worried about. So I should not have maybe erased it. I think if you wrote okay, so Saket notes in chat that a plus b divides 65. Okay, so we have to use divisibility. That would have been nice. So a plus b is 32 minus c. So 31 minus a plus b divides 34 plus a plus b. Oh, you didn't do a bounding argument. Okay, you guys did some other argument. Yeah, I think that's faster, definitely. So let's see what Saket is saying in chat. So 31 minus a plus b divides 34 plus a plus b. Why? Where do you get it? 31 minus a plus b is 1 minus c. Oh, this one below. Oh, you're writing this one, is it? Okay. So c minus 1, you're writing it as 31 minus a minus b. And 66 minus c, you are writing on the top as 66 minus 32 minus minus a minus b. And this is 34 plus a plus b. Correct. That is true. And so what? So is that it gives you a bound? Is that the point? No, but that bound is obvious. 31 minus a minus b is less than 34 plus a plus b is obvious. Maybe you mean some other bound. If you subtract a and b, minus 31 plus 31 if you do. Oh, is that what you're going to do? The standard trick where you try to write this as, okay, so let me erase my bounding technique. Let's try to do by divisibility. There are two ways to go about this always, right? I mean, divisibility or bounding. There are many of these problems. Okay, so you can try to, I guess, add, subtract A plus B. Expected cutoff for Delhi, I have no idea, going anonymous. So 31 minus A plus B divides 65. Yeah, that's what. So I understood what you meant. So you add 31, you subtract 31. So 65 plus A plus B minus 31. Yeah, that's what I was about to do. So I think that's what you meant. Yeah, 31 minus A minus B. And if you do this, you will see that it will be 65 by 31 minus A minus B minus 1. So therefore, you will get 31 minus A minus B divides 65, right? So therefore, you know that the factors of 31 minus A minus B are few cases. That's correct. That's very fast. Factors of 65: 1, 5, 13, 65. Because A, B, C are positive integers that add up to 32. So obviously 31 minus A minus B is positive, right? So these are the only 4 cases you have to try. And if you try these cases, you will get A plus B. By the way, A plus B can't even, 31 minus A plus B cannot even be 65, because then A plus B will be negative. So there are only 3 cases to check actually. Very nice. That's fast. Thank you. So A plus B is 31 minus 1, which is 30, or A plus B is 31 minus 5, which is 26, or A plus B is 31 minus 13. 31 minus 10, 21 minus 3, 18. So A plus B can be either 18, 30 or 26, but the sum is 32. So we can get the value of C also from there. So once you get the value of C, we are done actually, right? Like you can plug in here and try to get from this equation, you can get whatever you want. So A plus B is, I could have done that here only, no? I could have done that here only. Written this as 66 minus C by C minus 1. I could have simply written it as same logic. Okay, 65 plus 1 minus C by C minus 1. It would have been 65 by C minus 1 minus 1. And then C minus 1 should divide 65. It has only few factors. You try all the factors. That was the answer. Anyway, so C can only be 4, 6. It was very fast if I noticed there. Okay. What to do? So 18, 20, 12, 14. Okay. So C can be 6, 2 or 14. That is when 26, 30 or 18 A plus B is. And once you get what is C, 6, 2 or 14, you can plug in here. And you can sort of solve for A as well. So which one works? So if you put C is 6, 60 by 5 will work. If you put C is 2, so what? So we are almost there, right? Yeah. So as Saket notes, put A minus B is 60 by 5, which is 12, or 60. So A plus B is 12, or C is when A, this is when A plus C is 6, which is A plus B is 26. This already gives you the answer, right? A is 14, gives you A is 14, or A minus B is equal to, are there more solutions? Why does it go wrong though? So 2, oh, A minus C can't, if C is 2, 64, A minus B is 64, then A can't be like bigger than 32. That's why. Okay, so this is not possible. And if C is 14, what is the problem? 52 by 13. 13 fours are, this is 4. So, and A plus B is 18. So A minus B is 4 and A plus B is 18. Why not? Who's stopping me from making this work? What is this? 22. A is 11. If you add, and B is 2. What's the problem with A11, B2 and C14? C is 14, right? 25. Oh, it's not adding up to 32. I made a mistake somewhere. 14 plus 18. Sorry, A is 11. A plus B is 18. So it is B is 7. B is 7, sorry, B is 7. Yeah, what's stopping me? A is 11, B is 7, C is, oh, okay, I see. A must be greater than C. That's all. Okay, done. So is this because there's symmetry in ABC? Why did they say that? Is there a symmetry in AC in the problem? No, I don't know why they said A greater than C. Okay, anyway. So they wanted one solution, I guess. There are two solutions. They wanted to focus on one solution. So A is 28 by 2, 14. Answer is 14. Okay. So I took long time for this, but this was okay. For me, this is a tricky problem because of I went along the wrong path. Instead of divisibility, I used bounding. It would have taken long time for me. Problem number 14. Okay, problem number 14. Initially, there are 3 power 80 particles at the origin. 0, 0. So it started at 0, 0. At each step, the particles are moved to points above the x-axis. Okay. As follows. If there are n particles at xy, then there are floor of n by 3 of them are moved to x plus 1, y plus 1. Why do you need floor when they've written only power of 3? Okay. Okay, 1/3 of them are taken. Okay, we get it. Fine. So now, after 80 step, the number of particles at 79,80 is. I think there should be a pattern essentially that we have to now work out. What is that pattern? So essentially, if you are here, then what you do is you n particles xy, you move x plus 1, y plus 1, x, y plus 1, and okay. So alright, so basically 1/3, 1/3, 1/3. Yeah, that's correct. So then you do this. Okay, so this starts getting counted twice essentially when you do. Correct. So I think that's what they're saying, right? For each step, the 3 power 78 particles here. Yeah, that's correct. So this is 0, this is total 1, then it becomes 1/3, 1/3, 1/3, then it becomes 1/9 and 2 by 9, 2 by 9, 3 by 9 and 1 by 9, 4, 7, 9 by 9, yeah, and so on. So what is the pattern? So essentially what's happening, it's like some kind of Pascal's type triangle, is it? Like you, I mean not like that, but you mean sort of add three things at a time. So what would be the contribution next? I think if you see once more, you'll see it. So 1 by 27. So this like this, like this, like this. So essentially here there will be 2, now it will be 2 by 27. The ends will start having 2, and then you can have 3. All the remaining can maximum have 3 actually. When you split off, there will be 3 by 27, right? So you can't have more than 3, right? Anyway, so it's like 3 by 27. 3 by 27. 2 by 27 and 1 by 27, right? Something like this. Is this correct? 1/3 of that. Can't believe this is true actually. So in 3, must have made a mistake. So what is the 1/3 of this will go here, 1/3 of that will go here, 1/3 of this will go here. Okay, so I think I see. That's the mistake. I should add up to 27, right? One should add to 1. I'm like, what's going on? Okay, so essentially there is a 2 times here and 1 times here, so it's 1 plus 2. Okay, so 1 by 9, 1/3 of that, and 1/3 of 2 by 9 was adding, so 1 plus 2. So 1 plus 2 here, similarly, symmetrically, and here 1 by 9, 2 by 9, and 3 by 9. So here you have 1 plus 2 plus 3. Okay. However, here you have 2 plus 3 plus 2. And similarly, you have on here 1 plus 2 plus 3. 1 plus 2 plus 3. So, what do you have here? What is the pattern? What's the pattern? If you look at, so you're always adding the 3 above and dividing by 3, right? That's what is happening, like 2 plus 3 plus 2 by 9 by 3 here, and this is like that. In that sense, I said it's like Pascal's triangle. So it's like you're adding the previous 2 on the top to go bottom, right? It's like that. So what is this now? What do they want? Anyway, what is the question? The question is, after 80 steps, the number of particles at 79,80 is, I see. How would we find a formula for this? It's like 1, 1, 1, 1, 2, 3, 2, 1, and 1, 3. Okay, the way this pattern goes, 1, 3, 6, 4, 3, 4 plus 3, 7, 3, 2, 1, 6, 3, 1, 10, 27, yeah. This and also sums up to 3 power n instead of 2 power n. Very Pascal-y situation. So there is a Pascal somewhere here. So can we write it in terms of binomial coefficients or something? So what would 79, what is the question now? What is 80th step? What is the number of particles of 79,80? I think we can sort of see a pattern. What will happen next? We know actually 1, 4, 10, 16, 19, 16, 10, 4, 1. So it'd be like 20, 31 into 2, 62, 70 to 81, correct? That's up to 81. So what, okay, so we start out from 0, 0, and what are these numbers? Do we have a nice formula for them without recursion? This is 4, 6. Maybe you can just see a pattern, and I mean, maybe you just need to. It's expecting only 79,80, right? 79,80 means in this, where is it going? You don't need to know the full formula for the problem. You just need to see the particular pattern. So 0, 1 and 1, 1 and minus 1, 1. So 2, 2, like that, all the way up to somewhere here 80, 80, and you're just one step before that, no? In the question 79, 80. Okay, so you're like one step before. So I guess that pattern might be easy to write. right? That's all. So this is like 1 1 1 1 1, this is 1 2 3 4 5, I think. Yeah, because the pattern is to add up the last 3. 4 1 0 is what you'll write here, 5. Next you'll write 6 and so on. So in row 1, okay, that's it. So in row 1 you are at 1, in row 2 you are at 2, and so on. So when you reach 80, you would guess that this number is 80 here. So you will have 80 by 3 power, okay, so that depends on what, 3 power 1 here, 3 power 2 in second row, 3 power 1, 3 power 2, 3 power 3, okay, 3 power 80. So you should have 80 by 3 power 80. So therefore if you go here, after 80 steps there will be 80 by 3 power 80 fraction of the original 3 power 80 particle. So the answer will be 80, I think. I hope I have not made silly mistake or something. So the answer is 80, I think. Because they are 79, 80. I mean, if they are somewhere in between, it would have been actually a tricky question, I suppose. Okay. All right. So 13, 14 we are done. Let x be the set consisting of 20 positive integers. The smallest value of n for which any 3 numbers a, b, c belong to x, not necessarily distinct, form the side of an acute angle triangle is. Okay. So let's try that. Okay. So let x be the set consisting of 20 positive integers n, n plus 2 up to n plus 38. The smallest value of n for which any 3 numbers a, b, c belong, not necessarily distinct, form the sides of an acute angle triangle. So acute angle triangle condition is what? It is, there is some issue with the, okay, hopefully this screen is visible. So n, n plus 2, n plus 38 you have, right? So the smallest value for which any 3 numbers a, b, c not necessarily distinct. Oh, not necessarily distinct. Okay. Form the sides of an acute angle triangle is. Any 3 numbers, okay. So what is the condition? The condition for acute angle triangle is if a, b, c are sides of the triangle, a square plus b square and c square should have some condition, right? What is the condition? A square plus b square must be greater than c square. Well, I mean, I always check for equilateral. Equilateral is acute, right? And there this will be true. So I think this is correct. It's greater or lesser, I'll forget. That's why. Okay, so a square plus b square is greater than c square. If I add any two square, its sum must be greater than the third fellow square. So this, or obviously in this 3, when you are trying to compute any 3 numbers, if you are doing this will be the among any 3, the one that will be the deciding factor will be when c is actually the maximum value. If you take c to be the maximum possible and a square plus b square are the 2 minimum values, I mean the smaller values of this, just 2 smaller sides, even then it should be greater. So when is that guaranteed? So let's say you took the smallest 2 sides like n square and n square and n plus 38 square, the largest possibility. When will this happen? If 2n square, when is it greater than n plus 38 square? I think always true, most likely, right? I think you want a lower bound, and this is not a good idea. 20 positive integers. If n square plus n square only is greater than n plus 38 square, then any other you pick, it will be greater, right? I mean, if you pick any k, l, j, 3 sides in the triangle here, n square plus n square is greater than are equal to k square plus L square, because k and L are between n and n plus 38. And how are we sure it is greater than j square? Well, it's greater than, but 2n square only is greater than, okay, no, I can't say that. So k square, obviously k square plus L square is greater than n plus 38 square, and n plus 38 square is greater than j square, because j is again between n and n plus 38. K square plus L square, but why is it greater than n plus 38 square? That's not obvious, sorry. So I think the correct thing, what should I do here? I want this inequality actually. For any k square and L square, k square plus L square must be greater than n plus 38 square. When will that happen? If you took 2, what is an obtuse triangle? What's exactly the condition? Okay. N square plus n square. N square, 38 square. If I pick any two, so I think that's not the weakest bound. What if you take n plus 37 and n plus 37? Will that be worse? This bound is not good enough. We want this bound to hold. Strictly greater. 24th. So somebody is asking, Artworld is asking, what about the 24th? I don't know whether I've solved 24th. So let's see, have I solved 24th? No, I have not solved 24th. So let's consider a set f of all polynomials whose coefficients are in the set 0, 1. Let q of x be x cube plus x plus 1. The number of polynomials p of x in f of degree 14 such that the product is also in f is, no, I have not solved this. So of x by x cube plus x plus 1, the number of polynomials p of x in f of degree 14. This is q of x. The number of polynomials p of x in f. 14? What's so special about 14? Such that P of x into Q of x is again in F. Basically, you don't want carryover to happen. Okay, this should be doable, I think. So if we take Q of x is like, I mean, this is essentially, okay, so you want degree 14, and basically if you try to multiply P0 plus P1x up to P14 x power 14, I mean P14 is 1 because it's degree 14. So then if you try to multiply this fellow with Q of x, then what will you get? You will multiply, get a 17 degree polynomial for sure. And what's the issue? The issue is that if you look at the constant term, it is P0. If you look at the coefficient of x, it is, yeah, okay, I see what is the point. So P1 plus P0, see, that's the thing, P1 plus P0, you don't want it to be 2, so that will force P1 plus, and P1 P0 both can't be 1, that's one constraint. So when you get x square, the only possible way you will get x square is P2 x square into 1 plus P1 x into x, so P2 plus P1 into x square. Because of that x cube, I mean x plus 1 business. So then when you go to x cube though, there are lots of situations that start happening. So you'll have P0 into x cube plus P1 into P2 into x square plus P3 x cube. So you will get this x cube and so on. I think we can continue writing, but it's not worthwhile. You can analyze it for a while. Okay, 52 marks, all right. Sounds like a good score. So P0, P1 plus P0, P2 plus P1, P0 plus P2 plus P3. I would say, I don't know, it looks like 50 is a good score here, this paper. So P0, okay, let's see. So you can't have this, P0 can be anything, 0 or 1. But P1, if P0 is 1, then P1 can't be 1, right? So if P1 has to be 0, then P2 can be anything. Let's see, do I want to write down all the formulas here? What happens to x power 4? We'll write one more and see if there's some nice pattern. After a while, there should be a pattern, I think. So what happens for P4? For P4 onwards, you should have contribution for x cube will come from, I mean, in general, if you write some x power n here, okay, dot dot dot. So if you write x power n, in general n greater than or equal to 4, then you will see that the contribution will come from like Pn x power n multiplying 1, then you will have Pn minus 1 which will multiply x, and Pn minus 3 to get x power n. Okay, that will go on for some time, up to for 14. So now what is the recurrence here? Maybe we should do this by recurrence relation or something. The number of such polynomials, can we do it by recurrences? Sure, counting directly. Set of P, set of all polynomial quotients are 0, 1. number of polynomials of degree 14 such that p of x into q of x is also in F. If p of x is in F, p1 and p2 are in F, then their sum is also in F, right? Difference is also in F. Oh no, but you can't guarantee the 0, 1 coefficients. You can go modulo. Can you read it modulo 2? Oh, but no, but that will kill solutions. Can you go from degree if you reduce it, I think maybe you can do it by some kind of recursion, because if p0 is degree 0, I mean p0 is 0 or not, like 2 cases or something, and then you can sort of do it by recursion maybe, because if p0 is 0, then what will happen is that it will start from x onwards, right? So it's like a degree 13 polynomial multiplied by x, right? So would that help me do a recursion? How many degree 14 polynomial? p0 is 0 or not? If p0 is 1, what happens? p0 is 1. If you go forward, does it fit? If you go forward, like from the top powers, will it give some condition? X power 13, x power 13, p13, x power 16 can be 0 or 1 actually. So how do you count this? How do we solve? Each of them can only be 0 or 1. What happens? The maximum it can, one thing is we could count all and subtract, but maybe that's a bit too much. It's not easy to subtract the solutions here. System of equations which have lots of common. p0 plus, okay, so is that the pattern? p0 plus p2 plus p3. Next is like n is 4, so p1 plus p3 plus p2, p1 plus p2 plus p3, and so on. Each one can be 0 or 1. (27th). Can anyone tell answer to 27? Sorry, I don't know whether I've solved it. No, I have not solved it yet. Let me solve this problem. Pippa, I have not solved 27 problem. This is a set of polynomials. I've solved 23 though, it's 31. I'm now thinking about 24. How do you solve 24? It's actually tricky. Even can I solve how many are there of degree, smaller degree by the way? Forget 14. How many are there of degree, say, I don't know, same question but change degree 14 to degree general, like degree 2 or something. Okay, degree 4. Obviously, can't be degree 2. Degree 4. One level higher, right? So then it would be like P0, the solution would be very short, right? So then the answer would be P0 plus P1x into x cube plus x plus 1. P1 is forced to be x, and we are done, right? So in that case, oh, well, let's just add. Okay, well, let's just see. So obviously P0 can be 0 or 1. So essentially, yeah. If 1, it won't work. X plus 1 into x plus 1 will give you x square plus 2x plus 1, which has a 2 there. It's not possible. So there's only one solution. Right, so, oh, but that works here also, no? If P0 were 1, we cannot allow P1 to be 1. Oh, it only adds more actually. I see. So you cannot allow. Okay. I see. So maybe there's a recursion. So if you put P0 plus P1 x plus P2 x square, and again do x cube plus x plus 1, then you will get essentially x power 5. Again P0 plus P1x. So P0 can be 0, P1 can be 1, let's not look at the P0 as 0 situation. First let's look at P0 as 1. Then P1 is forced to be not 1 already, that we know. So P1 is 0, right? And once P1 is 0, then P2 can be 0 or 1. Okay, so once P2 is, okay, now but here P2 can't be 1 because of the third one. Oh, I see. So if P0 is 1, P2 is 1, this will become 2, it's gone. So P2 is forced to be 0 actually. P2 is forced to be 0. So, and P3 is also forced to be 0 because P0 is 1 already. So P3 is also forced to be 0 in general, like in the general 14 case also. So but is that going to fix everything, 0 or 1? So the next thing after P0, P2, P3 is P1, P2, P3. So now that P1, P2, P3 will automatically be 0 because all of them got forced to be 0. So then the next step onwards, there is no interaction. So what will happen is that P4 can be anything. So you'll have like P0, P2, P3. I think we wrote for P1, N is 4, S1 is 3, P4, P1, P2, P4 actually it was P1, P2, P4, and N is 4. So P1 was 0, P2 was 0, so P4 was either 0 or 1. So we had a choice for P4. And that was again free, I think. It's now a new free variable. So is it something about up to x cube there was some problem, but then onwards x power 4 onwards there's no issue. Okay, so basically the moral of the story is P0 is 1 instantly forces the first 3. We'll do up to that. I think then it will repeat in pattern. So P0 can be 0. If P0 is 0, then you can again ask what happens to P1. Can P1 be 1? I think if P0 is 0, then it just reduces down to one lower case, 13 case, right? Because just like taking any 13-degree polynomial and multiplying by x, P0 is 0. So I don't have to redo it, but I guess I think it will come again in units. Like if the moment P1 becomes 1, it's the same logic. It will force the next few to be 0. And again P5 onwards, we have a choice. So I think what's happening is if you multiply let's first consider P0 to be 1, then any polynomial in x power 4 is the only next thing you can do. That will instantly force a bunch of things around it to be 0. I see. So maybe there's a nice polynomial way to say this. Some basis method, I think. Some x power 4, 1 x power 4, x power 8. Let's just see. It's 510. Okay. Alright, so I need to finish this. So 1 x power 4, x power 8. X power 4 into I see. So if you have any polynomial if you have any polynomial that goes in units of 4, it will not have an issue actually, right? Because x power 4 into x cube plus x plus 1 will not interact with x cube plus x plus 1. I mean the powers only won't interact. The lowest possible power here is 4, degree is 4, and here it's 3. So it's, I think, this argument seems to show that be careful about the boundary conditions. Like P13, we cannot tell what it is, but just like x power 17, x power 16, x is x power 13 into x power 3, but there is no, but x power 15 into x power x, yeah, so this is not complete. This is P13, P15, oh there's no P15, okay, so that's why P is correct. X power, yeah, that's the boundary situation, 16. And next is x power 15. So again by x power 14 multiplying x, or x power 12 multiplying 3. X power 12 multiplying 3, or x power 14 so on. X power 14. From now onwards there is no issue. So 1 plus P13 plus P11 X power 14. So now you start seeing that P12 is forced to be 0. Again, same sort of logic. This is 0, this is 0, this is 0. So P12, P11, P13, everything is becoming 0. I mean P12, yeah. P13 seems to be, P13 is also 0. So this is 0. So you start seeing this pattern again. And P13, P12, P11, three things became 0. So it's like X power 14 and P13, P12, P11 is 0. So then the next best thing is X power 10. The coefficient of X power 13 can be P10, P12 which is 0 and P13 which is 0. So P10 X power 13, which there is no issue. So there is no contradiction with P power 10, I think, right now at least. So what are the options? Units of 4. I think the point is plus 1 P4 X power 4 so P4 is 1, P5, if n is 5, what happens? P5, P4, P2, 0 or 1. What is the answer? If P4 is 1, it will force P5 to be 0. P6, P5, P3 is 0 or 1. P5 is 0, P3 is 0. P7, P6, P4 is 0 or 1. If P4 is 1, P7 and P6 will become 0. P6, P7, P5 is 0 again. I see. Okay, so we sort of see what the pattern is. Okay. from the top we see that x14 is power is, I mean, it's a degree 14 polynomial, so x power 14 coefficient is 1. That immediately means by, okay, so the pattern is that if you have a 1 somewhere for some degree, then for the next 3 numbers it will be essentially 0. Like for example, if you have like 1 in the constant term, then x square, x cube coefficient is 0. If x power 4 you put 1, then x power 5, x power 6, x power 7 is 0. X power 8 we don't know, you can put 1 if you want, or you can put 0 if you want, it's your choice. So, but the moment you put 1 somewhere, the next 3 will become 0. Okay. And conversely, we are noting from the top, if you come from x power 14 down, you see the same thing goes backwards also. So if you put 1 somewhere, then the bottom 3 are like x power 14 coefficient is 1, and we saw that x power 13, x power 12, x power 11 coefficients were actually 0. So then x power 10 you have a choice. Okay. So basically the moment you put 1 somewhere, the point here is the previous 3 and the next 3 get forced to be 0. That is the pattern in this problem. Okay. So now we should be able to count because we know exactly the pattern. So what is the constraint? So I think this is what we figured out. So let's see. So okay, so I want to finish this problem and leave, I think. So I'll continue the rest at some other time. So let me finish off this particular problem. So I think, what is the plan now? What's our understanding? So if you have like 14 locations, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Degree 14 coefficient, I mean, this is the coefficient of 14 is 1 because it's a degree 14 polynomial. So we are solving problem 24, right? Consider f is the set of all polynomials whose coefficients are in the set 0, 1. Let q of x equal x cube plus x plus 1. Then the number of polynomials in f whose of degree 14 such that p of x into q of x is in f is also, I mean, is also in f is equal to. So basically the thing is that since it's of degree 14, as we saw, all the coefficients up to x power 13, x power 12, x power 11 were actually 0, is forced to be 0. Okay, if not, when you multiply by x cube plus x plus 1, you will see a 2 appear somewhere. Okay. Now x power 10 you can choose whatever, right now not decided. But if you put a 1 here, it immediately remaining will get forced to be 0. Okay, that's one constraint. So you have a choice to keep putting a 1 or not. You have 2 choices here. You have 2 choices here, but then it will automatically like force the next 4. So how do you count this now carefully? So it's like you can do case by case, but that might be too much. So you can put 1 here, then instantly 0, 0, 0, or you can put a 0 here and then decide to put 1 for the first time somewhere. So I guess you could say from here, let it look, there are 10 things, right? So starting from 10, I can either put a 1 here, or I can put a 1 here, or the first one that appears, we can decide it to be somewhere. Okay, so the first one, let's say, appears at some point k. Okay, so let's say at some point k1, first one appears. Okay, at some point k is 7 in the drawing, and the rest all are 0 until then. Okay, the first one that appears, and then instantly, and that k must be obviously that k, should it be, yeah, no, the k can be anywhere actually. So that k can be anywhere from 10, 9, 8, 7 all the way up to 0, I think. So if you take k anywhere, instantly the next 4 numbers will become 0. So if you put it at k, then k minus 1, k minus 2, k minus 3, k minus 4 are all 0. So then you have a choice at k minus 5. Okay, and no matter what you do, you can't put more than 3 ones, right? If this is a condition, Can't put, even if you put a 1 here, 0 0, what's the maximum number of 1 you can put? Another 1 here, sorry, so 3 zeros, sorry, here 1 3 zeros 1, so the maximum number is 3, right? So you can check where to put those 3 ones. There should be a gap of 4, a gap of 3 zeros at least. So either you can put, I think that maybe that's how we can brute force count. There can be 3 ones, 2 ones, 1 1, or 0 ones. Those are the different cases, and we count all of them maybe, and then we can be done with it. So where and all can you put a 1? The key thing is between any 2 ones there should be at least 3 zeros. That's the condition. How can you put, how many different ways can you put at most 3 ones from 0 to 10? So that between any 2 ones there's at least 3 zeros. How do we count it? Put a 1. I don't want to do brute force. Actually, you can brute force it now. I just do trial, just list everything out. How do we do? Shreyas Puja says, which question is this? This problem, Shreyas, is problem 24. Consider the set F of all polynomials whose coefficients are in the set 0, 1. Let Q of x be x cube plus x plus 1. The number of polynomials P of x in F of degree 14 such that the product is also in F is. Solving that problem. So I've been thinking about it for quite some time now, and we saw some pattern. I mean, basically you just multiply it out and just check. You'll get some conditions. Those conditions will force you to note that if at any point you put a 1 in these equations, it will force you to put zeros for the remaining nearby. So if there is a 1 anywhere you put, it turns out in the coefficients, if you put 1 anywhere, then the surrounding things should be 0 like this. These things should be 0. Okay, so that's the pattern. So that's why I'm just trying to count. So actually I think often at this point most people will start counting by, because in IOQM trying to be clever, there's no time. So you just think for a while. If you can't be clever, you just literally count directly maybe. But I don't know how big this can get. So, but I guess then there can't be too many. So if you put 1 here, immediately it will force 3 zeros. And next you can put a 1 here or not. Zero. Or you can move this one here anywhere you like, 3 of them. You can keep it here. And then you can try to move this one as well. So if you put 1 here, I wanted to sort of count it in a clever way. So should I consider 0 0 1 as a block or something? Maybe we can, right? 0 0 1 could be a block, but of course, yeah, 0 0 1 can be a block. But the problem is that the full 0 0 1 block need not appear. There can be 2 zeros here. So if you put a 1 here, the next few could be 0. That maybe is the block, 1 0 0 block. Then here there will be a problem. So I think you can put a single 1 and then use 2 1 0 0 blocks. And then say, and 2 zeros, in how many ways can you permute them? That should work, I think, right? 1 0 0 0 0 1 0 0. This is one way of saying it. Or you could say, for example, I think that's correct, no? Put 1 1 here and take a 1 0 0 block. Call this block X, call this block Y, but they're identical. And 2 zeros. In how many ways can you permute x x 0 0? Would that be reasonable? Or, I mean, that will be 4 choose 2, 6 ways actually. So there are 6 ways of permuting that. If you put 2 blocks of them, but are there other ways of doing this? Why not 0 0 1. Then the moment you did that, you still have to put 3 zeros after this, at least. And we're going to put 3 zeros at the start. 1 0 0. If you decide to put one more block of 1, 3 zeros and another 1, then it's already gone. It crosses 11. This is like 4, 8, 9, 10, 11 already crossed. So I don't think you can put 3 zeros and 2 blocks of 1. So if you want 3 ones, I think there's no other way. If you put a 0 here and put a 1 somewhere farther away, that you can do, I think. Or maybe we should just count directly from here actually, instead of putting on one line here. How many ways can you arrange? This already is an interesting counting problem. How many ways can you arrange ones and zeros such that 2 consecutive ones have a gap of at least 3 zeros? Maybe, oh, it's just, oh, that's all right. This is x1, this is x2. I think the number of zeros you're putting is at least 3, right, in between. So I think can't we do some divider method like stars and bars? The answer for 27 is 27 itself. Which problem is this? 27. I was trying to solve 24. So the question we are solving is problem 24. The one with the polynomial 0, 1, x cube plus x plus 1. And we have just tried to reduce it to, we have tried to reduce it to some other counting problem, and now that counting I am thinking how to do, that's all. So basically you want to arrange ones and zeros in such a way that if you put a 1, then surrounding it should be 3 zeros at least. I mean, if it's on the boundary, it's fine. But basically between 2 consecutive ones, there should be at least 3 zeros, at least. There could be more. So Wilma Fernandez says if f of n is the number of nth degree polynomials which satisfy the given property, f of n plus 1 is f of n plus f of n minus 3. Or you read by recursion. So f of n plus f of, you can do it by recursion. Let's see. Why is that true? F of n is plus f of n plus 1. Yeah, that's correct. So I can see the recursion sort of happen. F of n plus 1, if you have degree n plus 1 polynomials that have with that property, then you can have p0. I mean, in my mind, the p0 coefficient is what? p0 you can put 0. You can take any polynomial of 1 f of n degree and multiply x to it. So that way you'll get f of n, such polynomials, by multiplying x. Or there is one leading coefficient is 1. I'm sorry, the last coefficient is 1. And if the last coefficient is 1, then the next 3 will become 0. So then it will be x power 4 into something, whatever remaining. So x power 4 into some p of x, kind of a, p dash of x polynomial. That's what p of x looks like. Okay, so so how many solutions are there with p dash of x again as that property? So why is it? It's n plus 1 minus 4 is n minus 3. Yeah, f of n minus 3. That's correct, I think. That's correct. That is a recursion. Then you have to write out to the recursion and solve. That's correct. Okay, so how do we solve this though directly? I want to do by some stars and bars kind of method. I mean, yeah, by the way, recursion is one way to solve, as Vilma Fernandez says in chat. Because you can, by the way, I think hopefully everyone understood what the recursion is, why the recursion appears, how I got it. I mean, how, I'm guessing Vilma Fernandez is Rishan, I'm assuming. So maybe Rishan said the same thing. So basically in this problem, the recursion goes like this: let the number of polynomials polis p of x in f of degree n such that p of x into q of x is in f is some f of n. Then we note that if you have any, like if you want f of n plus 1, let me write the recursion the way Rishan wrote it. If you have f of n plus 1, n plus 1 degree polynomial, okay, then what will happen is that if you take any n degree polynomial with the same property, I can always multiply x to x, right? Like if you have p of x is a solution to this equation, x into p of x is also a solution, okay. So basically, I mean, x into p of x also has a property that its coefficients will be 0 and 1, okay. So you can sort of solve one for a, I mean, find one in the set with degree n and multiply x to it to get one solution in degree n plus 1. So there are that many solutions which you get by multiplying x. So what it simply means is, when you try to write out the n plus 1 degree polynomial, the last coefficient p0 can be 0 or 1. p0 plus p1x plus p2x square, whatever. If you write this polynomial, this is a plausible polynomial. You just try to break the case p0 is 0 or not. If p0 is 0, that means it's a polynomial that is divisible by x. So if you factor x out, it becomes 1 degree lower polynomial. So the total number of such solutions is f of n. Or p0 is 1. If p0 is 1, then p1, p2 and p3 will be 0 from whatever you have argued already actually, okay. So p1, p2, p3 is 0, and p4 again you have options, you can either put or not. So it basically becomes 1 plus p0 is 1 plus x power 4 onwards, you take that, factor it out, and what will remain is a degree n minus 3 polynomial. So for any degree n minus 3 polynomial satisfying this property, we can work with it, right? It will work. So you can basically, essentially the total number of solutions is therefore another f of n minus 3. So therefore that is the recursion. I was directly trying to, in this case, I was directly trying to write out 1 0 0 0 without doing recursion, but I guess if I tried, I think there must be some stars and bars style technique or something to do it. But it's getting a little tricky when in the boundary you cannot get the full block. I mean, I can't take the block 1 3 zeros to directly do the count, because I also have to resort to recursion. So essentially the number of ones can vary. The number of zeros you put, I think you can say like there are, let's say there are k ones, x1 at x2 location, at x3 location there is 1. Then in between the gap must be at least 3 zeros, minimum of 3 zeros. Somehow I have to put it to do the count. Okay, so anyway, we can do it by recursion as Rishan notes and see what the answer is. I think you need initial conditions though, but for this recursion, a little painful. But so for example, f of I guess maybe f of 3, how many degree 0 polynomials is, maybe the either easy base cases like f of 0, how many degree 0 polynomials exist which with that property, coefficients coming, so I think 2, right? F of degree 0 is both, degree 0 polynomial is a constant, so both 1 and 0 will work, I think. So f of 1, degree 1 polynomial is, I mean there's a gap of here 4, no? The gap of 4, which means like initial conditions you need 4 level initial conditions. So f of 1 is 1, right? F of 2 is, what is f of 2? f of 2 would be quadratic polynomials with that property. So essentially p0 plus p1x plus p2x square into x cube plus x plus 1 must be a polynomial with only entries, should be a polynomial with only 0 or 1 entries. And when you do this, you will see that coefficient of, if either p0 is 0, how many possibilities are here? I think it already forces, because coefficient of x square is 1, it will already force p1 p0 to be 0 actually. So I think there's only one choice here, 2. I think x square is the only thing. If you put anything else, you will be in trouble, I think. Like for example, if p0 were 1, then I think you will get 1 into x cube and x square into x, it will add up to 2. Okay, if p0 is 0 and p2 is 1, even then you will be in trouble, I think, because you will get x into, well, will be in trouble, x into 1, no, x square into 1 and x into x will add up to 2. So indeed, whatever our logic is working from earlier, I'm just indicating that. So directly you could have said it's 1. And f of 3 also, I think, very similar. F of 3 also, if you put x cube here, you will see that since the leading coefficient is 1, the next 3 things must be 0. So again, you can't have anything. So I think these are the initial conditions. So you have essentially 4 level initial conditions which are direct. Then you can just compute. So for example, f4, put n equal to 3 is f of 3 plus f of 0. And f of 3 plus f of 0 is 5. And f of 5 is f of 4 plus f of 1. F of 4 plus f of 1 is 6. F of 6 is, I think, f of 5 plus f of 2, which is 6 plus 1, 7. And f of 7 is f of 6 plus f of 3, which is 7 plus 1, 8. F of 8 is f of, what is it? F of 7 plus f of 4, which is 8 plus 5. Now it starts adding. 13. F of 9 is, okay, so we are sort of seeing the pattern now, right? So you just have to add 8 plus 5 is 13. To get to 8, it was 7 plus 1, right? So 2 numbers you have to skip and add. Okay, so 2 numbers you skip and add. Let's be faster. 19. Then you again skip 2 numbers and add, which is 26. 11, 12, 13 and 14. So 26 plus 8 is 34. 34 plus 13 is 47. 57, 67, 66. 66 plus 26, 80, 92 maybe. Okay, I don't know. So I'm getting 92 as the answer here. I might have made some mistake, but essentially you get a recursion, and using the recursion you can solve. But I would like to solve this directly too, so I'll think about it later. So I think directly also you should be able to solve this without recursion. Right, so this is somebody asked me 24th problem. So that's why I did this. So I think I've not done any geometry. So maybe I'll do one full session of just geometry, because people kept asking algebra questions. Maybe geometry was very easy. That's why nobody's asking geometry in chat. Which ones did we do? We finished all this actually. So 15, 16 we have not done, and then next is geometry. Okay, so I have to leave now. So I'll do a second half. I think how many problems remain? I'll do that maybe later. So 15, 16, 17, 19, 15, 16, 17, 19, 22, 15, 16, 17, 19, 22, 5, 5, and then the last 5 problems, 10 problems. Okay, 10 problems remain, I think. Okay, 10 problems remain. All right, so see you all. I think I will stream maybe tomorrow or whenever I'm free for the remaining. But streaming is me sitting and solving, and you guys can hop in, give some comment or something like that.